Hey everybody, it's Caleb, and welcome to the first video in the Linux and Unix video series. So this is going to be a pretty comprehensive video series where we start from the complete beginning of Linux and learn all the details to get to an intermediate and maybe even some advanced stuff as well. Now, again, this might be a little bit slow to start with if you've had some experience with Linux. If you're looking for something that's a little bit more to the point, I created a mini series on Introduction to Linux. The reason I'm creating another series is because I want to spend more time talking about the details of each command and really understand at a deeper level. So to understand Linux, you should first understand what an operating system is. So this is another example of an operating system, Mac. So you can see this allows us to run software on our computer, such as Google Chrome. Windows is another big operating system, and the one we're going to be using is Ubuntu. So this allows us to do similar things, such as open a web browser. You can see it's just a little bit different in the way it looks and the way it works. So again, the operating system allows us to run different software on our computer. So it's an abstraction layer from the computer hardware down here, then you have the operating system, and then you have the software. So I can write software to run on an operating system, and it doesn't matter what hardware that operating system is running on, as long as they have that operating system, then they're good to go. Another way to think about that is the creators of Google Chrome, they don't have to create a version of Google Chrome for every single combination of computer hardware out there. They just write Google Chrome to run on Mac, Windows, and Linux. So the idea of an abstraction is it hides those details. The operating system is what deals with the details of the computer hardware. So this just being a complete beginner introduction, maybe that was a little too deep, but that'll make more sense as we go on. So you'll often hear the terms Linux and Unix. What exactly are these and how are they different? Well, you'll often hear Linux as Unix-like, so it's very similar to Unix and inspired by Unix. One of the biggest examples of Linux is Ubuntu, which is this operating system you're looking at right here, but there are a lot of different distributions, another popular one being Fedora. What these different operating systems that are all considered Linux have in common is they're all built on the same kernel known as Linux. The different variety, well, those are known as distributions. Think of the kernel as the core of the operating system that does the majority of the work, and then there's just software written around that to make these distributions unique. So they all share that same core, and thus they're going to have very similar commands, and they're going to be used in very similar ways. They're not going to be exactly the same, but if you're familiar enough with Ubuntu to be able to open up the terminal and type in various commands, well, then you'll probably be able to move to any of these other Linux operating systems just fine. So that's a good thing. If you learn Ubuntu, for example, most of those skills are going to move to any of the other operating systems that all share that Linux kernel. Now, what about Unix? Linux is said to be Unix-like. It was built as a variant of Unix, but there are still Unix-based operating systems out there. A popular Unix operating system that you've probably heard of by now is actually Mac, which is a Unix-compliant operating system. So you can go in here, open the terminal, and type various commands that are going to be very similar to what you would experience on Ubuntu. So Mac actually came from FreeBSD, and here's a little wiki talking about some of the myths about FreeBSD, and it talks about Mac OS here. Alright, so far so good. We have Linux operating systems, an example of one of those being Ubuntu. We have Unix operating systems, an example of one of those being Mac. And we also have Windows. Where does Windows fit in this entire list? Well, Windows is not a Unix-like operating system at all. It's its own entire thing. This makes things challenging because now the commands don't work on all of the operating systems. A command that works on Mac or on Ubuntu isn't guaranteed to work on Windows. This can be frustrating, especially if you're trying to learn these commands and you want a computer to work on. So if you're on Windows, there are some things you can do to issue the same exact commands. For example, you can download MinGW, or you can install the Windows subsystem for Linux, or WSL. However, the easiest way I think to get started with these commands is to use a virtual machine or an operating system on the cloud if you know how to do that. That way you can get the exact same experience. You have the operating system running on your computer, and it's just inside of another window. See, you can actually minimize it here, and see we have Ubuntu, and we're running Mac. So this is an example of a virtual machine, and this is how I would recommend getting started. That way, you follow along exactly instead of kind of making it match for Windows or Mac or whatever operating system you're on. Now, between different Linux operating systems, it's going to be fairly similar. So if you're on another Linux operating system, not Ubuntu, or if you want to follow along on your Mac or Windows PC, you're probably okay to do such, but there just might be a few more challenges that you might need to figure out on your own. If you're looking for a more comprehensive list of the different options for Linux out there, there is a Wikipedia article here, Linux distribution, and you can scroll through here and learn about the different varieties. So for example, here's Ubuntu, derived from Debian, and a bunch of other ones on here as well. There's a lot of vocabulary thrown around, and it's not always 100% clear. For example, people argue, is Mac really considered Unix? Well, it is a Unix compliant operating system, but the experience is going to be a lot different than you might get on Ubuntu or these other Linux operating systems. For a complete list of the operating systems out there and a more table-like comparison, here's another Wikipedia article, Comparison of Linux Distributions, and you can get a complete list here with tons of information. As you can tell, it's very overwhelming, and I don't expect you to have all this down. I don't have all this down. I'm constantly learning, and doing this series is actually an attempt for me to better understand these operating systems as well. I do like Ubuntu, however. It's free, it's very easy to use, and there are a lot of apps built on top of Ubuntu, so pretty much anything you could get on Mac or Windows, you can get some Ubuntu variant. Ubuntu will always be free of charge, which is a great thing to have when you're building computers and you don't want to pay for an operating system. Well, that's all I have in this video. This was just supposed to be an introduction to the different concepts. In the upcoming videos, we're going to talk about how to actually get started, get a setup so you can start issuing commands, and anything else that you might need to know. So stay tuned for the upcoming videos. Thank you for watching, and I'll see you then. Peace out. Hey everyone, welcome back to episode 2 of this Linux series. In this video, we're going to talk about how to actually get started with a Linux operating system. Now, there's lots of ways to do this. There's not necessarily the best way to do it. I'm just going to talk about some different options. Starting with the absolute most simple way to do this, which is to just use a sandbox website to try out commands. Now, this isn't the best long-term solution, but if you're ever just wanting to experiment with some commands, you can just go online and look up a Linux sandbox such as this one here from Octal. You can run terminal now, and we can open up some project. Eventually you'll be able to open a terminal here, and you can start typing commands such as ls or pwd, kind of tiny, but you can pretty much follow along using this here. So we'll type clear, and that will remove everything from the screen. And now type uname space -a. Hit enter, and that's going to tell you what version of operating system this is running. And you can see right here, we are on Ubuntu 20.04.1 Ubuntu. So we'll clear that. So this is a Ubuntu terminal. Even though it doesn't look like the Ubuntu operating system, it's still running the same terminal here. It's just the CLI instead of the GUI. So CLI, command line interface, that's the terminal. The GUI, graphical user interface, is when you have all the little buttons and you click them. And an operating system can have both. Another cool website to test out any of these operating systems, and there's a lot larger variety, is this website distrotest.net. And in here, you can go through all these different operating systems. So for example, we can find Ubuntu, scroll in. Looks like there's numerous with the name Ubuntu in it. So we'll just go with the default Ubuntu here. and you can go into one of these and hit start. It'll give you a little waiting timer, and eventually it's going to launch this operating system. And you can watch it boot up. Another cool thing about this is you actually get the GUI as well. When you get to this page here, you can just hit try Ubuntu, and as you can tell, it's a little slow. This is obviously for trying out the operating system, experimenting. Might not be something you want to run a web server off of. And this website is nice because there's a ton of different versions of Linux out there, so you can test them out, see which ones you like, which ones you don't like, and once you find the one, then you can worry about installing it locally or on another computer. Alright, you can see it's finally done, and you can follow along like this. So you can go down to the apps down here. And I'm hoping once we actually get the terminal up, it'll be a little bit more responsive. So you should be able to issue commands here. So just wanted to share that website as well. It's probably not as useful because there's also a time limit. It's slow as crap. And yeah, you really only need the terminal for like 99% of this course. So yeah, just kind of throwing that out there more as a way to experiment with other distributions. Watch your time limit. Don't leave anything important on there until it gets ruined. But yeah, cool way to try out other Linux operating systems. What the heck? A Hannah Montana Linux operating system? Count me in. Holy crap. Why is this a thing? Why haven't I tried this earlier? Anyways, where was I? I'm getting distracted here. So these are some tools to try out Linux. When you want to install Linux, and it actually works pretty good, and you don't have to worry about your session getting destroyed or anything, I recommend a virtual machine. For Mac operating systems, if you want to run the virtual machine on a Mac, I recommend the Parallels software. It's the easiest to use. You just download it and you just literally click through it and it'll install Ubuntu. You don't have to worry about any ISO or anything crazy like that. It does it all for you. The downside is it does cost money after the trial period, so for some of you that's not going to be an option. My next recommendation is actually, I forget what it's called, VirtualBox. Now VirtualBox, I have an M1 Mac and I was having issues getting it running. I don't know if that's related or what, but you can try VirtualBox as a good alternative, which is also what I would recommend if you're on a Windows operating system. So this is VirtualBox, and it takes a little bit more effort to get things set up. You're also going to need an ISO for the operating system. So what is an ISO? Well, think about an ISO as a file that represents the operating system. So you can go download Ubuntu, and that file type is going to be .iso. You're going to need that to launch a Ubuntu instance. And you can find that by going to the Ubuntu website, ubuntu.com, and then download from here. Now, I actually ended up using Parallels, which I think is by far the easiest, and it runs very smooth on Mac. However, not everybody is going to have that. The last option is if you get that ISO, you can actually flash it to a USB stick using a software like Balena Etcher. So this will allow you to actually install the operating system on a USB stick. Once it's on that USB stick, you can boot your computer to that USB stick. If you go into the boot options when the computer starts, usually you'll hit like F2 or something. You can choose that USB stick and it'll give you the option to install Ubuntu on that system on the solid state drive for that computer or whatever you're running your operating system on. So that's a little bit too detailed for this video, but if you're looking to have Ubuntu installed directly on a machine, then that's the route you're going to want to go. I did a video which was a complete step-by-step guide on building a computer, and I'm by no means an expert, so this is like for dummies for sure. And this will go through the actual process of building the computer. And then part 2 will be how to actually install the operating system, which you can find on this video here, which literally takes you through that entire process of how to flash a USB stick and how to install that on a computer. I don't want to have to repeat the same thing, so just go ahead and watch that video if you want to know the details on how to do that. So to conclude this video, because there's a lot of information, if you want the simplest, easiest way to get started, just go to a sandbox environment online. There are a lot of Ubuntu sandboxes. If you want a good solution for Mac, then I'd recommend Parallels. If you want a good solution for Windows, then I would recommend VirtualBox. Or you can install directly on the hardware using a flashing software like Balena Etcher. Now there's another option, which for Mac is also fairly easy, which is you can just use the terminal on Mac because 90% of the commands are going to be exactly the same. So you can type out all these commands and you can see it's working just fine. That's because we're on a Unix operating system, which is very, very similar to Linux. For Windows, I probably just download Git. When you install Git, you can also get the git bash mingw thing. So yeah, download Git at git-scm.com. This will allow you to run a lot of the Linux commands on Windows. Or if you don't want to download Git, you can download mingw right here. That's all I got for you in this video. Stay tuned for the next video. Now that we have it installed, we're going to talk about how to actually start using it. So that should be pretty cool. Thank you for watching. I'll see you in the next one. Yo everybody, in this episode, we're going to become more familiar with the GUI of Ubuntu. So we're going to learn some tips and tricks on how to work with the operating system. I know many of you watching are probably interested in the commands, which those are going to be coming very soon. So to start, let's go over to my virtual machine. Boom. And we're not going to be using the terminal in this video quite yet. All right, so we're going to talk about the basics, because if you're starting with this operating system first time, even some of the most simple things can be challenging. So we have 10 little tips and tricks that might make your life a whole lot easier. The first one is, how do you actually turn off the computer or restart? Well, it's with this little power button up here, and then power off/log out. And then you can select power off, and then you can choose to restart or power off. Simple as that. So that's the first one, pretty simple. The next is settings. So we want to enable dark mode, obviously. So we'll go to the settings, and then on the left side, appearance, and you can choose light, standard, or dark. I'm going to go with dark. The third thing I want to show you is how to prevent the display from shutting off, which I just like my screens on all the time. So this is actually in power. Blank screen, I set mine to never. Now tip number 4 is how to open applications. Pretty simple. You just go over down here to these little square dot things and open up all the different applications, and you can select any from here, such as disks. So when there's something you're going to be using a lot, what you can do is you can set it as a favorite. So you can actually search in here. For example, the terminal, you can right click, add to favorites. And what that's going to do is, I'm just hitting escape to get out of that. You can see it now shows up over here on the side. Even if it's not open, it's there to open. So that works similar to Mac, where you can have these different applications even if they're not open. So the little dot below us says that it's open. Same thing with Ubuntu, so we can open that terminal and there's a little dot there saying that it's open. Tip number 5 is to change the update settings, which is just something I like to do. So I'm going to go to the applications and I'm going to search updates, and we're going to go with software and updates. Then select updates, and here you can customize your update settings. So for example, if you never want to check for updates, you can just do that, type in your password, and you're good to go. Now I want to talk about how to work with disks. So I'm going to close out of that, open up our applications, then you can search disks, or you can find it right here. And this is important, especially if you are running Ubuntu directly on a computer and you want to see different USB sticks or hard drives. This is where they're going to show up. So this little square here, this is saying it's already mounted. So if you want to unmount it, you can select that. When you put in a hard drive, it might not mount automatically, and you have to open up this disk app and mount it manually using a little play sign. You can also get information about the file system type. In this case, it's FAT. Next up, I want to show you how to view the files from the root directory. So you can go into this file system, and this is the root directory, which basically is the source of all folders. All folders are inside computer. So another way you can find that is from the left here. You can click other locations and then computer. So sometimes when you're given a path to a file, it might not be in your user directory, which is in this home folder. For example, it might not be in downloads. It might be something like /dev. And in that situation, you would go to other locations, computer, and then find that dev folder. And there you go. So that's how you find all files. Next up, I want to talk about how to take a photo. Just why not? Let's just do that just for fun. So we'll open up applications. And from here, you can type cheese. And this is the camera app. So you can go in here and hey, there I am. Be sure to subscribe. Next up, I want to talk about how to edit text. So this is pretty important. The application you're going to use actually has a much more descriptive name, text editor. And you can open this, and here's where you can write documents or open already existing documents. You can also download other applications off the internet, such as Visual Studio Code. And the last thing, which I already showed you, number 10, is how to open the terminal. Well, you can always just right click and open in terminal. And there you go. You can do that from pretty much any folder. So if we have some folder open, let's say downloads, you can right click, open in terminal, and it'll be in that path. So you can think of the terminal as just a different way of navigating these folders. And in the context of Linux and the terminal, they'll often be called directories. So you can navigate through the different directories. So you can do the same thing visually as you can in the terminal, but it's often good to know a little bit about the GUI if you're working with visual things such as photos or videos. Well, it's kind of hard to do that in the terminal. So it's good to know a little bit about both. For those of you who've used Ubuntu, this video is probably stupidly simple. But for those of you who are brand new, these are all like the little things that you don't have to worry about. You just want to know how to do them. So hopefully that got you up to speed with the GUI. In the next episode, we're going to start learning some of the commands. So stay tuned for that. Be sure to subscribe, and I'll catch you in the next video. Peace out. Hey everyone, what's going on? In this episode, we're going to learn the absolute basics of working with the terminal in Linux. Now, again, this is like, I've never used the terminal before. I have no idea what I'm doing level of video. If you already have some experience, this might be a little too basic, but a little review never hurts. So let's just jump into it. The easiest way to open the terminal is from your applications. You can just type in terminal, right click, and I'll add it to my favorites. So that way it's always over here on the side. Now, as I mentioned in the previous video, you can right click on the desktop and say open in terminal, but I wanted to call out a little difference here. Notice this here, the prompt, this one up here has a tilde and then a $sign. Whereas this one down here has a tilde / desktop and then the $sign. So you can see these are basically in two different folders, where this one that we opened by right clicking the desktop actually opened into this desktop folder. Now from this point on, I'm going to try to call them directories. As mentioned, when you're working in the visual Ubuntu, it's very easy to call them folders. I mean, they're even visualized as folders. But I don't think people called them folders until the GUI came around and people became really familiar with things like Windows. But in the terminal, they're called directories. So this is located in the desktop directory, and this one is in the home directory. So what is the home directory exactly? Well, that's as if you went to the folders and went to home. It's where all of your personal files go. So that is the default directory when you open the terminal, and you can always see where you're at by saying pwd. Hit enter, and it'll give you a path /home /parallels. So that is the name of my home directory. Now the next thing I want to talk about is the word clear. This will clear off anything on the screen and give you a fresh start. Often useful if you need to have some mental clarity, or you're trying something new and you just want to have a clean slate. Now what I want you to type is man space bash. Hit enter, and this is going to open the manual. And this is a very comprehensive guide with a ton of information. You can navigate using the arrow keys, and pretty much anything you'd ever need to know you can get from within the terminal. So you don't always have to go Google something. So for example, and you can exit this by hitting Q, you could say man space and then some command like ls, which is a popular command to display folder contents. So we'll hit enter, and you can see the manual entry for this, as well as all these different options. So /A//C and so forth. Some of these things are hard to look up on the internet, just being single characters. So whenever you need some extra information, you can always use the man pages and see what a particular option is. So for example, -L, use a long listing format. And another popular one we're going to be using is -A, which do not ignore entries starting with dot. In other words, it lists all of the entries. Now we'll hit Q to exit out of that. Now another trick is that when you're on this prompt, you can use the arrow keys up or down to navigate previous commands. So the most recent thing we just executed was man ls. Then if you hit the up arrow again, man bash, and then again was clear, pwd, and so forth. So you can use the arrow keys like that. Just a quick way if you want to execute something again, or if you made a typo. You know, let's say we said man lss, and you're like, oh man, that wasn't right. You can go up and then just delete that last character. Beautiful. All right, so let's clear. The next useful command is cd, which means change directory. And to always find your way back home, you can use the tilde, which is right next to the 1 key, and you hold shift. Hit enter, and that's not going to do anything because we're actually already in our home directory. However, if earlier, remember I opened the terminal from the desktop, well now we're not in the home directory. So what we could do is we could say cd tilde, and it'll change our path to the home directory. You can do it the other way around too. So instead of changing directory to the home directory, we could actually change directory to the desktop. And you may have noticed there that I jumped and it filled in desktop. Well, the way you do that is you just type a few characters such as DES and then hit tab and it'll fill it out. Hit enter and there we go. And then PWD to see your path. And you can see we're in home, parallels, desktop. Now, whenever you want to copy something, for example, this here, and you say Control C, well, it does this weird -C thing in the prompt and doesn't copy what we have highlighted. So Control C is not going to work. You actually need to right click, copy, and then if you ever need to paste, you right click, paste. That's the most important thing to remember in the terminal, especially because if you're not careful, you can mess something up. Oftentimes you will have an ongoing process going. You know, you might be downloading something or running some server or something, and you're trying to copy. So you hit Control C. Well, this is actually the command to quit whatever is happening. So you might be trying to copy something, but you might actually kill a process. It's like, oh crap. It seems like something, you know, maybe it'd be better to have different key combinations, but that's just the way it is. So I want to show you this by teaching you another cool command, which is sleep. So let's first clear. And what we're going to do is we're going to say sleep 10. And when we do this, you can see the prompt doesn't immediately show up. It just shows like the cursor. And this is actually going to pause for 10 seconds and then display the prompt. So if you do that again using the up arrow, hit enter, and then immediately hold Control and hit C, it exits out of that process and goes back to the prompt. So it didn't wait that full 10 seconds. So if some process is running and then I try to Control C to copy, well, it's going to kill that process. And it doesn't even copy it. You can see when I paste, it still has the original thing that was copied. So yeah, in the terminal, don't use Control C to copy All right, so the next thing I wanted to talk about is the cursor. So if we go up and we say sleep 10 and we'll hit that, well, this little line, and yours might actually look a little bit different. I will be talking about how to customize it. Most likely by default, it'll actually highlight an entire character like so. And you can move to the left using the arrow keys, left or right like so. And if you want to customize a command, it's always going to put the new keys that are typed to the left of the cursor. So right now it'll be on the left of the S, and I can say man, sleep, and then I can delete the 10 over here. And it'll give us the information about the sleep command. So that's just a little bit of important information about the cursor. It can be a little bit confusing, especially if it highlights a character like so, but just remember that it's always going to put it on the left of that cursor. But I know you guys are super jealous of my sick cursor and theme, so I'm gonna be showing you how to set that up in the next video. Thank you for watching, stay tuned, and I'll see you then. Bye. Yo everybody, in the last video we talked about the basic Linux commands, and I know most of you are probably jealous of my sick theme, so we're going to talk about how I set this up to look a little bit custom. So pretty much there are different profiles you can use, and in this terminal drop down here there's this preferences, you can see that, and here's where all of your different customizations are going to come from, the default here being unnamed. So what we can do is when we create a new terminal window, there's this little drop down here and you can choose which profile you want. So I'm going to go with the default and it looks something like this. Pretty ugly if you ask me. I'm not a huge fan. I much prefer my look here, which is called Caleb. So let's take a look at what this profile looks like by going back to our preferences and going to the Caleb profile. And there's this little check mark here, which means it's verified. No, I'm just playing it. It just means that it's the default. So you can set one as the default like so, and that'll change that check mark to be with that profile. So when you open a new terminal, it's going to default to this Caleb profile. So the very first thing I did was, I just changed the font, and I didn't really care about what the font is, but I did increase the size, and actually I'm going to increase it a little bit more, and that's just going to make it a little bit better. There's also the initial terminal size. So what that's talking about is if you close out of the terminal and you open a new terminal window, how big that terminal is going to be when it's not in full screen by default. So it looks like it's just automatically going in full screen. So let's just test this. If we set the initial terminal size to 8 instead, or I guess 16 is the minimum there. So we'll set that to 16. And when we open terminal, you can see it looks a lot different because we now have 16 columns instead of 80 columns. Definitely doesn't look too good, so I'm going to put that back to 80. And that should make it look a lot better. So pretty much that's how many characters wide it's going to be. And I think the default is pretty much fine there, but I did increase the font size just for a better presentation for the videos, and I just kept it on the default font, but you might have a preference there. Next thing I did was tinker with the colors, and I went with this Tango Dark theme, and I like that pretty well. And then for the text, I went with the cursor shape I-beam instead of a block or underline. I'm not a huge fan of the block. That's the default, and that will basically cover characters, which to me, it can be a little confusing, especially for beginners if you're not used to that type of cursor. So I definitely prefer the I-beam. Now another thing I wanted to call out is that this cursor is blinking, which you can change that cursor blinking default to disabled if you like. And now you can see it's just a solid line, which for me makes it a little bit better for videos. So that way there's not like, if I make a cut, it's not awkward on the blinking there, like not, I don't know, I'm overthinking it. But anyways, that is how I set up my profile. Let me know your custom profile. Drop a comment in the comment section below. And also if you suggest any fonts. This video is way shorter than I was expecting, so sorry if it was useless. You can test these colors live, so I mean, we could go in here and you can change these different themes to see what you like. I really like the tango colors, but you could certainly do something custom as well. So that's how you get your custom terminal set up. Stay tuned for the next video because we're going to get back into some more commands. Peace out. Hey everybody, in this episode we're going to talk about how to list the contents in a directory, how to navigate directories, and how to become a master at tab completion. We've talked about some of these throughout the previous videos, but now we're going to go into more detail. So let's get started. So the first thing, we got our terminal window open, and to get everybody on the same page, we're going to change directory into the home directory. And then again, pwd, you can see that this is our path. Now the first thing is ls. That's going to list all of the content. And now we can add options after that. And you do that with a hyphen. So hyphen A, that's going to add a little bit of extra stuff because the A means all. And this will include anything that starts with a dot. So files are white here and they start with a dot, meaning they are a hidden file. So if you want to see that in the GUI, we can go to home and then click these three bars over here, show hidden files. So now you can see everything here. So I'm going to put these side by dragging them to the edges. And I'm just going to issue that command one more time just to get a clearer representation. So anything that's white here is a file, such as bash history, bash logout, bash rc, leshist profile, and then sudo as admin successful. So those are all of the files, and then anything that's blue is a directory or a folder, which these can also be hidden directories as well. So generally, if something starts with a dot, it means don't touch it. It's there for a reason, but it's not something you typically go into and change settings. Well, you might on occasion, but that's just a general rule. It's hidden for a reason, so you don't go in there and tinker with stuff. So let's go back into full screen. So that first option that we talked about, -A, is short for all. And you can also type out all, but when you use the full word, you actually use two hyphens, ls -- all. And it works the same way. Another option in addition to all is -l, and this will give us more details about each file, including permissions, size, date, and all that stuff. So when you have two options, if they both have a shorthand version, such as -a and -l, you can actually combine these into one. So here's the first way to do it, ls-a -l, or what you can do is you can just put them together, ls-al, and they're also able to be swapped, so you could do ls-la, and that works as well. So a quick summary on options, you can do two dashes with the full name of the option, or you can do a single dash with the shorthand of that option. You can combine multiple shorthand options just by using a single dash and putting each of the characters. You can get a reference for all of these different options by saying man and then whatever command you're talking about, such as ls, and you can scroll through here. Now, not all of them are going to have that long version. So for example, -l, the one we were just using, it only has the shorthand here. And the capital L is something totally different. You see, in Ubuntu and Linux, things are case sensitive. A lowercase l and an uppercase L are two different things. This isn't the case by default on Windows. All right, let's clear. So now I want to talk a moment about tab completion. So if you say something like CD and capital DE hit tab, it'll fill out whatever matches what you were typing. How does it know to do this? Well, let's just go back to our home directory, and when we say ls, you can see we have DE for desktop. Well, looking through all of these options, desktop is the only one that matches the start of what we're typing. So when we say DE, the only folder we could be referring to would be desktop. That's because documents and downloads are both DO, not DE. Now, if you are less specific and you do something that multiple things could match, such as CD with a capital D here, well, that could be desktop, that could be documents, or that could be downloads. When we hit tab, nothing happens. However, if we hit tab again, 2 tabs, it'll show all the options that could potentially match what we were typing. So it could be desktop, it could be documents, or it could be downloads. All these other ones, well, those don't make sense. Those don't start with a D. At this point, you can start typing another character, such as DO. Do double tab again, and it will say, oh, here are the options, documents, or downloads. That's because at this point, desktop no longer qualifies because it has DE instead of DO. And then once we distinguish by saying some other character such as the W, well, now tab will fill it out in its entirety. All right, cool. So let's go back, make sure we're in the home directory just so everybody's on the same page and clear. I want to talk a little bit more about this tab completion, and I want to issue a command mkdir, which is make directory, to make another directory, and we're going to call this down low with a capital D. Hit enter, and now ls, you can see we have desktop, documents, downloads, and down low. So if we type cd do, well, at this point, we could be trying to change directory into downloads or down low, but the computer doesn't know by default. Up until this point, we would hit tab twice and it would show us the options. However, because there is actually consistent characters between these, the W, N, and the L, as well as the O, are the same for these. We got down low and down low. When we hit tab just once, actually we have to be a little bit more specific by adding that W because documents matched as well. Now when we hit tab, you can see it filled out all the way up until it can't make a decision anymore. So it knew that we would have WNLO, WNLO, but it didn't know after that point. So now you can do double tabs and choose which one you want. So quick summary of that is single tab will autofill up until it doesn't know which choice you want, and then you can do double tab to see the different options. Maybe it's a little obnoxious for me to go through this in such detail, but it's not a tool I want you to skip. I want you to use this for all the upcoming videos because using the tab completion is going to save you from so many different typos and errors just to make sure you're actually selecting something that exists and not just assuming it exists. And this is important for other commands. So for example, if we go back to the home directory and we say touch, and we'll just go with down low. Well, I am using tab here, so I know it exists. And when I hit enter, I know that I'm issuing this touch command on a file that exists. What the touch command does, that's not really important here. I'll explain in just a second. But if we say something like touch, and let's just say I was trying to type it out and I used a lowercase d, well, when I hit enter, hey, it looks like everything worked exactly the same. Well, this first command actually updates the timestamp for that directory, whereas the second command creates an entirely new file. So when we say ls-l, we can see in here we have the down low directory, which has the latest timestamp, and we also have this new down low file that we created with this command here. So my point is, if you're trying to do something as simple as update the timestamp on a directory or a file, and you mistype it, you might actually make a whole new file. So by using tab completion, you can be sure you're touching a file that already exists and you're not pulling something out of the air. And the most common example of where this is going to happen, where you're going to make a mistake and you're not going to realize it, is probably with capitalization. Like here, I'm using a lowercase d, didn't even think about it. So let's go ahead and remove that file. We'll say rm down low. That's going to remove this down low file. And we can also remove the directory by saying rm down low as well. You cannot remove down low is a directory. You can just put another option in here, which is r, and that'll remove that directory. So now we're back to how we had it. And we'll clear the screen, and we are at a clean slate for the next video. So that was a lot of information. If you are familiar with these things, then maybe this seemed like kind of basic, but I think explaining it in such detail is important to really understand how it's working. So thank you for watching. I appreciate it. I would also appreciate it if you hit the like button, the subscribe button, and stay tuned for the upcoming episode. Peace out. Hey, what's going on, everybody? In this episode, we're going to take a look at paths, which is a way to describe the location of a file or directory. Now, there are two types of paths, and it's important to understand both and how they're different. We have relative paths and absolute paths. So let's jump into it by first talking about this command right here, ls-a for all. And this is going to include anything that starts with a dot, including these two here, which is the current directory and the parent directory. By current directory, I am referring to this path right here, and you'll often hear this as the working directory. The parent directory refers to this home directory, and it's relative to where we are currently at, which is this parallels home directory. So if I say something like ls space ... that's going to show the directory contents of the home directory. This home directory, not the directory we're currently in, which is parallels. So we hit that, and you can see the only thing in there is a directory called parallels. If you want to include any other options, you can do that here as well, such as la ... and you'll get all that extra information. We can use these dots to change directory and grab files relative to where we're at. So if we want to move up a directory, we could say cd ... and now we're in home. cd ... and now we're in the root directory. We can go back to our home directory by saying cd, and you can use a tilde. That's actually optional. You can just use cd by itself, and that'll take us to our home directory. So that's a little shortcut. There's a lot more you can do with the cd tilde, which we might look into that later, but for now, let's just get to the home directory, and from here, what I want to do is start navigating using these dots. So for example, if you wanted to go into the videos directory, you would say cd ... /videos. So in other words, from the current working directory, let's travel into the videos directory. And it ends with a / here, which is another way to say that's a directory. When you have that / at the end, it's typically optional. Basically, that's a way just to say, hey, this is a directory, but if you leave it off, it'll usually work just fine. So let's just go ahead and delete that, and that works. And then we can move back by saying cd ... and that'll bring us back. Now, another trick you could do is, let's say we are in the videos directory, and we want to travel to the last working directory we were in. You can say cd ... and that'll give the directory here, and it'll take us to it. So we've never done it this way before because this / is implied. So we could just instead say videos like so, and that works the same way. So let's try some more advanced navigation. What we're going to do is we're going to create two directories, and we're going to use the mkdir command. Now for this, you can actually put multiple directories here. So let's say we make a directory for home videos and a directory for professional videos, and hit enter, and now we can see these both exist in the videos directory. What we can do is we can change directory into one of these. Let's just jump into the professional directory. And now if we want to move to the home vids directory, the way we would originally do this is we would change directory to the parent and then change directory into home vids. And that works, but there's actually an easier way to do this. So let's go ahead and let's move back to the directory we were just in with cd-, So now we are in the videos directory. We'll actually just move one more into professional. All right, so we're back into professional. And if you want to jump to the home vids directory, all you'd have to do is you would say ... for the parent / and then we can see all the options and jump into home vids. And there you go. So that was a lot. So let me just review that. If we're in a directory and we want to move to a directory that is next to it, so we have home vids and professional, all we would do is say cd parent / professional. And there you go. These are all relative paths because the meaning of the dot is dependent on where we are currently at, our current working directory. So when we go up a directory to the parent or navigate into another directory, that all depends on what is available in the working directory we're currently in. So that's why it's said to be relative. Absolute paths, they're pure, they don't change depending on where you're at. So let's see what that would look like. Well, when we say PWD, this actually gives us an absolute path to where we're at. Home, parallels, videos, professional. And you can see absolute paths start with a /. This is the root directory. So if I say cd /, well, now we are in the directory that contains all other directories. So let's say we wanted to go into one of these. We'll just change directory into root. Oh, of course. We'll change directory into etc. And we'll see what's in here. There's a bunch of stuff. Let's just cd into one of these. It doesn't really matter. Into gnome. Now let's say we want to move back to our video folder. Well, let's do this with an absolute path. We would say cd /, and again, you can use tab to see all the options. Double tab. And this was in home, parallels, and then videos, and then professional or home vids. Hit enter, and there you go. That is how you navigate with an absolute path. One of the downsides with the absolute path is, let's say you have a directory and everything is working with whatever you're doing, and you move that somewhere else, then your absolute paths could break, whereas your relative paths could continue to work. And this is something you'll often see in programming. If you're referring to a file that is in a directory next to whatever file you're working in, well, you'll use a relative path. That way you can move that entire project around without having to worry about it. So it really just depends on what you're trying to do. I've used absolute paths if there's like a certain script I want to execute and I want to just be able to execute that from anywhere. Well, then I don't have to worry about relative paths. I could just say something like /home /parallels /script.sh. And that would refer to that script. And I wouldn't have to worry about it not being available because I'm using relative paths. That's all I have in this episode. It's kind of scatterbrained, but a lot of little things to go over. Hopefully it wasn't too scatterbrained and that you're actually able to get something useful from this video. Stay tuned for the upcoming videos. We have a lot more coming. See ya. And subscribe. Okay. Hey everybody. In this episode, we're going to take a look at renaming files and figuring out file types. Talk a little bit more about how files work inside of Linux. So let's not waste any time. Let's just get started. But first, let me waste your time by saying you should subscribe to this channel. You see, we are on a journey to reach 1 million subscribers. And I can't do that without your help and the help of 999,999 other people. So please do your part and help out this channel. All right, let's get back to it. All right, so we are in our virtual machine, and here's what we're going to do. We're going to first talk about files, file extensions, and whether or not they're important in Linux. So let's first create a file, and you can do that easily with the touch command. We'll just call this important.txt. Now, this .txt, you've probably seen this or something like this quite often in your journeys through computers. However, inside of Linux, this file extension is not important. It's only a name and doesn't actually tell the computer how to interpret the content of that file. So you can actually get the type of file by saying file important.txt, and you can see that it is in fact empty, so it doesn't know what's in this file. So we can put something in this file by saying echo hello world, in quotes, a greater than sign, and then the file name important.txt. So just to repeat what's going on here, we're going to say the phrase hello world, and this echo command will just spit it back out, but we're going to direct that output into this file important.txt. So let's try this out. And now we should be able to say file important.txt and see that the type is in fact ASCII text. So the type of the file was actually dependent on what was in the file, not the file extension. But in this scenario, we're actually using the same file extension as what's in it. It's .txt, and it contains text. So what I want to do now is actually want to change that file extension to something else, because again, it's not really a file extension. It's just a name that happens to end in .txt. So it's a little misleading, whereas if you're coming from Windows, this file extension is really important. Not the case in Linux, because it's just the name of the file. So what we can do is we can actually change the name of the file. Let's go ahead and clear the screen, and we're going to say mv important.txt, and we're going to change this to important.jpg. Enter. So now we see that important.jpg right there. So what we can do is we can get the type of this file by saying file important.jpg, but you can see it's still ASCII text. So it has nothing to do with this ending here and everything to do with what's actually in the file. So what exactly is in that file? Well, you can open it with a text editor. And let's go ahead and drop this down here, all files, and important.jpg shows up here. And this is actually really, I'm glad this happened because I was going to talk about this. So this can mess you up real easily. If you look closely, it does say hello world, but just because the .txt or the .jpg doesn't actually matter in Linux, oftentimes applications will still interpret files based on that. So it's still important to not intentionally end it in the wrong ending, because then if you try to open the text file in a text editor, it might not show up. So the lesson here isn't to say that you can just name it whatever you want. You probably do want to adhere to some conventions, but it doesn't actually change the type of the file, just how different applications might interpret it. So what we could do is if we change this from what it is now, JPEG, to just important without anything on the end. This is often what I'll do. I just won't end my text files with anything. It's still going to work just fine. And in a text editor, if we change this to all text files, that shows up just fine and is interpreted as typed text. So that was just a quick crash course on ending files with extensions inside of Linux. And do keep in mind, if you're doing anything cross-platform, if you're writing code, they're going to move to Windows, you probably want to keep the .txt or whatever extension at the end of the file name. One other command I want to talk about in this video is if you want to see the content of a file inside of the terminal, if it's text, you can use the less command. So if we wanted to open our file important, well, there we go. Hello world, and that's it. And you can exit this with Q. This isn't going to let you edit files. For that, you want to use something like Nano or Vim or some other terminal-based editing software. Or if you're using the GUI, you can just get something like Visual Studio Code or Sublime or whatever else might be supported on Linux. But less is very handy when you just want a quick preview of the file, and if it's a really long file, you can scroll through it using the arrow keys. Now I wanted to show you another thing is, what if we have a photo, but we label it as a text file? So what I want to show you this here is I actually took a photo using the Cheese application, and that went to, Pictures. And then in here, webcam, and then we have this file right here. So if instead of LSing into that, we actually used MV to rename it, we'll just rename it photo.txt, hit enter. Now, what does this command do exactly? Well, if we type ls, you can see we actually have that file in the working directory, not in the picture's webcam directory. So mv actually moves files as well. So we're moving this file from this directory to our current working directory, because if you remember, the // is implicit. So it's basically like typing // We're basically moving it from here to here. So mv will move a file, but it can also be used to rename a file. If you put the same directory, it's just going to rename that file, keep it where it's located. If you put a new directory, it's going to move that file from the previous directory to that new directory. So what that means is if we were to go to ls into pictures and then webcam, you can see there's nothing here to show. I'm slapping tab as many times as I can, nothing's happening. So that's the move command. If you don't want it to actually move, you can use the cp command for copy, but we're not going to talk about that quite yet. So back on track, what was I talking about? We have this file photo.txt, and we can say file photo.txt, and we can see that this is a JPEG image, and we can't fool it by saying, yo, this is a text file, because it knows that it's a JPEG file. Same thing when we open an editor, it might show up as photo.txt, but it's certainly not going to work the way we would expect. As you can see, it just gives us some like information stuff and says there's a problem opening the file. All right, so let's go ahead and change that back to a photo. So we will say mv photo.txt to photo.jpg. And now let's go ahead and take a look at that photo. Photo.jpg. Boom. Hey guys, it's me. That was a lot of scattered information, but it's all I got in this video, so hopefully it was helpful. I feel like I say every video is scattered, so I apologize about that. ADHD kicking in, I guess. Thank you for watching. Be sure to subscribe. I'll see you in the next one. Good morning, everybody. In this episode, we're going to talk about renaming, moving, and copying files, as well as a lot of important things you should know about it so you don't mess up everything. And I did want to give a special thank you and shout out to this book here, the Linux Command Line, which I'm going to go over most of the options they listed here. And this was a good help for most of this course as well. So shout out to them if you're interested in some reading material. So let's just jump into the commands. So the very first thing I want to do is I want to create a couple of files. So I'm going to touch two files, important and junk. So hit enter, and you can see these files exist right here. So the first command is mv or move. However, this is also used to rename stuff. So for example, if we wanted to rename junk to something like junk2, very creative, I know. Well, now junk no longer exists and junk2 does exist. It's the same exact thing, it's just renamed to junk2. But let's go ahead and put that back to how it was, as so. So now that's what it looks like. Now here's what I want to do. I want to put some stuff in these files. So we're going to say important stuff, and we're going to put that inside of important. And then we're going to say not important stuff, and we're going to put that inside of junk. And I'm doing this silly demonstration to illustrate a dangerous point with this command. If we look at our files now, we have junk, and let's say we decide that, hey, you know, the stuff inside of junk is actually pretty important. I'm going to rename it to important. So what we could do is we could say move junk and change that to important. The problem is it's actually going to overwrite this file here. And to show you that, I'm going to teach you a new command here, which is cat, and this will actually display the file content in line. This is different than less, which actually opens like a new interactive session. So we'll say cat junk and cat important. And now what I want to do is I want to say rename junk to important, hit enter. When we say ls, now we only have this important file. And when we look at the content, well, it was the content from the junk file. So one of the challenges of the terminal is that it usually doesn't give you warnings. You know, if you delete something, it's gone. If you rename something, it'll overwrite the other file. So you have to be very careful so you don't get fired or something like that. So what is the solution to this? Well, just double check before you actually do something. And also you can add a different option to prompt you if you want to overwrite something. So to illustrate that, what I want to do is I want to change the important file back to junk, and then I want to touch important. So now we have our original junk file, and we have this new important file, which is currently empty. And what we can do is we can say move junk into important, but add an option here of -I for interactive, and this will prompt you anytime you're going to overwrite something. Do you want to overwrite important? Oh no, I forgot. Important's actually an important file. I don't want to delete that. It's like my resume or something. So I'm gonna hit no, and now we can see that important is preserved, and we still have the original junk and the original important. Now there's two more variations I want to show you for this command. The first one is moving multiple files into a new location, and then the second one is actually renaming directories. So let's go ahead and try this out. What we're going to do is we're going to move the junk file and the important file, and we're going to put this inside of a directory. We'll just call it files. So this is the setup. Basically, you list out all of the files you want to move, and then you end with the directory you want to put it in. The thing here though is that this directory has to already exist. So you see when I hit enter, it says files is not a directory. So what we can do is we can say mkdir files, and then reissue that command. Now when we ls, we should have this files directory, and we can see what's inside of it with ls files, and we see that there is important and junk. So consider this a continual list where you can just add in as many files as you want, and then you end with the directory. Now, if instead of a bunch of files here, you actually wanted to work with a directory, then it's going to work just like as if you're working with files. So we would say mv files, and we could move this to something like docs. So that's going to, whoops, I accidentally messed that up. So that's going to rename it to docs. So this works exactly the same way as when we were working with files. If you remember just saying like mv junk to important, well now we're saying mv files to docs. So the only time that directory has to exist is when you're moving multiple files into a directory. Let's go ahead and move those files into the working directory. So to do this, I'm not going to change our directory. I'm going to do it all relative. So let's clear the screen here, and we'll take a look at the files. So we'll say mv docs / important, and then docs / junk. So we grab both of those files, and now we say the destination directory, which we can just use the dot for the working directory. Hit enter, ls. You can see we move those files over into this directory here, and then when we ls into the docs directory, there's nothing there. Okay, so that was a lot of little things. Basically, the summary is if you want to move a file, you just put the starting name and the destination name. You can include a path there too if you want to move from one location to another. You can also think of moving, when you're doing a rename, as just moving the file to the same directory and possibly giving it a new name. It's another way to think about it. That's the first thing. The next thing is if you want to move multiple files, then you'll put all the files and then end with a directory that is already in existence. Renaming directories works the same way as renaming files. You'll just start with the current directory name and then put the new directory name. Now there is also the copy command, which is cp. This is going to work pretty similarly. The only difference is that it's not going to remove the original file. So for example, we could say important junk, and we're going to put that in the docs directory. So now when we say ls docs, you can see those files exist there. And when we say ls, you can see they exist in the working directory as well. Now, one thing is if you say ls-l, you can see timestamps here. And if we do the same exact thing for the files in the docs directory, we can see that these have a newer timestamp than these here. And sometimes this is important, as you can actually set options to not copy files unless they're a newer version. And that is just an option you can add into the command, and we're going to show that process in the next video. So stay tuned for that. We're going to basically continue the discussion on move and copy. So thank you for watching. I'll see you then. Welcome back, everybody. This is a continuation of the previous episode, which was the basics of move and copy, which move is used to rename and move files, and copy is used to copy files. But I did mention there is an option you can add in there to only copy files if it's a new version, or if that file doesn't already exist in the destination. And that's what I want to show you in this video. So let's take a look at how I ended the last video, which was showing that we have two files, one called important and one called junk, and these are located in two locations. We have them in our home directory, which is our current working directory, and then we also have them in the docs directory. And you can see that these timestamps are older than these ones here. So if we were to say mv important and junk, and we wanted to move these to the docs directory, but we only wanted to do this if the current files were newer than the destination, then all you have to do is you add the U option, or update. But we'll just stick with the shorthand -U, hit enter, and now let's repeat these listings. So we'll list the current directory, and we will list docs. You can see that these timestamps were not changed, and it doesn't appear that anything happened. If you want to see file by file what's happening, if things are being replaced or not, you can add another option here, which is V for verbose. So we hit enter, we get nothing, and that's basically telling us that nothing is happening, no files are being moved or any files being replaced. And that makes sense because these timestamps are older, so it wouldn't make sense to replace these newer ones with these older ones, and that's exactly what this U option does. So we only want to update files if the source is newer than the destination. But let's go through an example where that's not the case. What we're going to do is we're going to touch another file. We'll just call this log. Now, when we issue this previous command and we add in the file log, it should move the file over as it doesn't exist in the destination. So we'll hit enter, renamed log to docs/log. Is exactly what we were expecting. Now let's go ahead and show another case where we change the timestamps for the files and see the same thing happen. So what we can do now is we could say ls-l for the working directory, and then ls-l for the docs directory, and we can compare these timestamps. So you can see that log was actually moved from here to here. If we go ahead and update a timestamp with the touch command, we'll say touch important. I don't want to touch junk. Now we can reissue that and see that this has an updated timestamp, 8:53. So when we move it into the docs directory, it'll notice that the important in the source, the current working directory, is newer than the destination, so it will overwrite it. So let's take a look at what that looks like. We'll hit enter. Oh, then it's giving us a problem because that log file doesn't exist in the current working directory anymore because we moved it. So we just want to move important and junk into docs. And when we do this, well, it worked the first time. So renamed important to docs important. So now when we take a look at the files in the working directory, you can see that important was moved because it had an updated timestamp, and we can see that inside of the docs directory. There we go. Now let's see the same thing with the copy command. So if we wanted to say copy junk to docs junk. And let's go ahead and add in our options. We'll add in U for update and V for verbose. And let's just add in I just for fun, interactive. So that'll ask us if we want to replace any files. So we'll hit enter. Right now, it does absolutely nothing because again, the timestamp for this junk is earlier. It's an older file than this one here. So let's just go ahead and do it. We'll touch junk. And now when we issue this command, it asks us if we want to overwrite docs junk. We'll say yes. And it responds that junk was copied to docs junk. So now we should be able to say ls-l, see that that junk still exists because we're using copy instead of move, and we can do the same thing for the docs directory and see that these junks are the same and it was properly copied from here to there. So that was a lot of information, but long story short, there's 3 options you should be familiar with: I for interactive, U for update, and V for verbose. I interactive is going to ask if you want to overwrite anything before it just does it. U for update, that's only going to move or copy the file if the destination is older or that file doesn't exist in that destination. And then the last one is verbose, which is going to detail each step that happens in the output. So a lot of information, but not too bad. That's why I wanted to reference the book and just say sometimes it's good to have some source of material that is text as opposed to video, just because you can then reference those different options. But again, as a reminder, you guys can always say man, MV, or CP, and you can go and see all these different options in here. There's a lot of other ones you can take a look at, but these commands work pretty similar, with the difference being obvious that copy doesn't delete the source. So thank you for watching, and stay tuned for the upcoming video. See you then. Peace out. Hey everybody, in this episode we're going to talk about the recursive option that you often see with commands, or it'll often be required if you want them to work. So you will see this when you are copying directories or removing directories, and maybe some other places as well. Little bug. Get out of my face. Subscribe. So taking a look at our current directory, we have a directory here, docs, that I'm going to take a look at. If we wanted to change the name of this, we would say mv docs, give it some other name such as docs2, and that works just fine. Docs was renamed to docs2. However, if you wanted to do the same thing with copy instead of move, let's first rename it back to docs. So we have docs. If we wanted to do the same thing where we said copy docs, and we'll make this docs2. So now we have 2 directories, docs and docs2. This is actually going to give us an error, -r not specified. So when you say man cp and you scroll down to -r, this copies directories recursively. And the idea of recursion, or anything being recursive, is the same thing happening over and over again. So the idea of the recursion here is that we want that same concept to happen with all the directories inside. So not only do we want to copy the directory, but we want to issue the copy for all the directories inside of it. And this is one of the things that is required for the copy command. So it's really easy to fix. All you have to do is just to put -r, and that works. So now we have docs and we have docs2. Simple as that. This is also going to happen when we want to remove directories. So if we say rm docs, it gives us a problem. And it doesn't give us as nice of a response here, where up here it says what to do. Here it just says it's a directory, and then you're left with, what do I do? So then you might have to go Google or figure out what to do. This doesn't happen with files. If we rm junk, it just goes away. So if we want to remove a directory, we just put -r and then throw in the directory name, docs2, and we'll just go ahead and get rid of docs as well. Now there's another command you might run into when you're working with directories, and that is rmdir, remove directory. So rmdir works a little bit differently because you don't actually have to specify the -r to remove stuff. So if we create a directory, we'll just call it docs, we can rm this with the -r, and that works fine, and it no longer exists. To do this with the rmdir command, you do not have to say -r. So we would just say rmdir docs, and that works the same way. So why exactly is there two commands to do the same thing? One where you have to specify an option and one where you do not. Well, rmdir is very special because it cannot remove a directory with stuff inside of it. And this can save your butt if you're trying to remove empty directories only. So if you want to remove directories with stuff in them, you'll need to use the rm-r command. So let's take a look at an example. We'll say mkdir docs, and let's just create a file in here, and we'll just call this test, and that needs to go in the docs directory. So now inside of docs we have this test file. I probably could have just said touch test, but whatever. Let's go ahead and say rmdir docs. Failed to remove docs directory not empty. So this can be very handy if you want to skim through a directory and delete all empty directories. So to show you this, let's go into this docs directory, and I'm just going to say mkdir dir1, dir2, dir3, dir4, dir5, and then I'm going to just touch some files. We'll say dir1/file, dir3/file. So I created a file in dir1 and dir3, and I can say rmdir asterisk, which is a wildcard. There's all kinds of crazy things you can do with these, but this will basically represent everything. And in general, it's very dangerous. You will see this in horror stories with the rm command, where people rm-rf asterisk, and that'll basically delete anything in that working directory is gone. So it's pretty dangerous. That's why rmdir remove directory can save the day. When I hit enter, you can see it fails to remove directory 1 and directory 3, whereas everything else is now gone. If instead we said rm-r asterisk, that's just going to remove everything. No questions asked. There's also the F that I mentioned, -f. So you might see rm-rf. The F, which we're not going to get into the details of in this video, it stands for force, and will be a little bit more forceful in the remove more files even if they're read-only. It's a pretty dangerous option, and it'll bypass the interactive option, so it's not going to ask you if you want to delete anything. Overall, it's a pretty dangerous option, but still kind of cool. So that is my video on remove directory, and all that other junk. Hopefully it was helpful. Stay tuned for the next one. Appreciate you. If you made it this far into the series, you're doing really good. Just want to encourage you to keep going, and encourage you to slap the subscribe button. And yeah, like the video. Peace out. Hey everybody, welcome. It's Caleb, and we are now starting the section on redirection and dealing with standard output and standard error. So a lot of cool stuff coming up. Hopefully you guys are excited. So I wanted to start by first showing you two different ways to create a file. The first being the touch command, and this will allow you to just put a file name and it'll show up as a file. The other way is you can actually use the greater than symbol and then give a file name. We'll just say file2, and this will work as well. So there's a really important difference that you need to understand between these two when it comes to starting to learn about redirection. The first is that the touch command will just update a timestamp of a file if it already exists. So if we say ls-l, that's going to show all the timestamps of last modified, and we can see 1119 for file and file2. If I go ahead and say touch file again, and then we say ls-l, you can see it's now updated to 1120. Let's go ahead and put something in this file. We can do that with the echo command. We'll just say hello, and I showed you this in previous videos, but this is actually redirection in action. We'll just put that inside a file. And when we take a look at what's in that file, we can do that with cat. We can see it has the value hello. If we go ahead and we touch file again, this doesn't actually change the content in the file. This is very different than if we were to use the greater than symbol, because basically what we're doing is we are redirecting nothing into this file and it replaces everything inside of it. So if I go ahead and do this, well, that's going to replace the content of the file. So now it is empty. So to quickly summarize that, you can use the touch command or you can use the greater than symbol to create a file and update the timestamp of a file. Touch will create the file initially and then update the timestamp, whereas the greater than symbol will always replace the content of the file or create a new file. So what exactly is redirection? Because we're actually using it here. When we say echo hello, this greater than symbol is known as redirection, and we are redirecting the output into this file called file. We're doing the same thing here, but in this case, we're redirecting nothing into that file, which is why it becomes empty. So again, redirection will take the output of some command, in this case echo hello, and put that inside of a file. Now it doesn't actually put everything inside of that file, it only puts what's known as standard output. There's also standard error, which we're going to talk about in the next video. Now you also have the option to append to a file. So let's see what that looks like. If we say echo, and we'll just say issue, let's pretend something goes wrong in a script or something, we can append that to a file. We'll just call it log.txt, for example. When we do this, well, it's going to first create that file. So now we have log.txt. And we can check what's inside of that. It has the value issue. Well, if we run into another issue, but we are appending, well, it's just going to continue writing that in the file. So now we have issue in there twice. So one greater than symbol will replace everything. Two greater than symbols will append. Now this is going to take the standard output for any command and put it in this file. But you can do this for pretty much any command. So for example, we could say ls-la and direct that into a file called list. And now when we say cat list to see what's inside of it, you can see we get the same exact output that we would have gotten if we issued this command and got the standard output inside of the terminal. The only difference is it puts it in a file now. So when we issued one of the echo commands earlier, such as this here echo issue, basically what it's doing is it's taking the output of this command and putting it in that file. Well, the output of this command is actually just going to be this value, and that's exactly what the echo command does. So this was a very basic introduction to redirection. So far we've learned how to redirect standard output to a file. In the next video, I want to talk about standard error, which standard error is if there's an error with your command and that error shows up in the terminal, well, that is another thing we want to deal with. So I'll see you in the next video where we're going to learn about that. Peace out. Hey everybody, welcome. In this episode, we're going to start talking about standard error and redirection of that. So this is like a little mini series on redirection. Check out the previous video in this series, which introduces redirection and standard output. Now we're going to learn about another form of I/O, standard error. So there's actually 3 forms of I/O with Linux. You'll often hear the words file descriptor, which is an integer to describe this I/O. So we have standard input, which is 0, standard output, which is 1, and standard error, which is 2. And that's going to be important for this video. So just remember that 2 is standard error. So we learned about redirecting standard output, and let me just show you an example of that real quick. If we say ls and we redirect that to something like a file called list, when we hit enter, we don't get any output in the terminal, and when we take a look at the list file, you can see the output showed up here. But if there happens to be an error in our command, something goes wrong, well, that's still going to show up in the terminal. And a common example of this is if you were to ls for a directory that doesn't exist. I'll just call it nope. Well, now it's going to say that that directory doesn't exist, and it's going to put that output inside of the terminal. ls cannot access nope, no such file or directory. And we can say cat on this list file and see that it is empty. So we figured out the difference between standard output and standard error. One is for when it's working, standard error is when it's not working. If you're redirecting standard output, standard error still shows up in the terminal. So they're two separate things. So let's take a look on how to redirect standard error. So if we say ls nope, which is a directory that doesn't exist, and let's say we want to put this into a file called error. Well, you can put a 2 right here to say you want to work with standard error. And that's where that 2 comes in. So we hit enter. And now, if we take a look at the error file, you can see that error shows up inside of that text file. Now the same thing happens here, where if the command actually works, well, then it's going to show up in the terminal. So if we say ls, well, standard output shows up in the terminal and nothing goes to the error file. So we are going to talk about how you can do both to a single file or to two separate files, and that's all the kind of stuff we're going to be talking about in the upcoming episodes. But first I wanted to show you a neat little trick, and it has to do with a particular file which is in the /dev directory, and there's a bunch of stuff in here. And the one you might see on occasion is called null. So you can see it right here. And in computer science, the term null refers to a void or a lack of a value. So if you have a database, for example, and somebody's missing their phone number, well, that would be null. It's the absence of a value. Well, it's a pretty similar concept here, where any redirection to this null file is just destroyed and doesn't exist anymore. So you may see something like this, where you redirect standard error to /dev/null. And basically, this is a way of saying, I don't care about the errors, you can just flush them down the toilet into the black hole of dev null. You may hear of this as the null device or as the bit bucket. And there's a lot of memes around this too, like please send complaints to dev null. In other words, we don't care, and so forth. So that's pretty cool. All these redirections and examples might seem silly with just our simple commands, but you can imagine using these commands to your benefit within a larger shell script, or if you have some complex command that's going to output a bunch of errors or a bunch of data, you can direct that appropriately and not pollute the terminal. So lots of cool things you can do, and now you understand the basics. But now we need to figure out how you can do it a little bit more better by redirecting standard error and standard output at the same time to two separate files or to the same file. And that's what we're going to be looking at in the upcoming episodes. So stay tuned. I'll see you in the next one. Don't you dare forget to subscribe. If you have any comments, questions, or concerns, please be sure to drop them in dev null. All right, peace out. Hey, what's going on, everybody? Welcome back to your little series on Linux, and we're specifically talking about redirection now. We've talked about standard error, standard output, and how to redirect those, but now we're going to talk about how to redirect to multiple files. This can be useful if you want to have an error log and an output log as well. So let's talk about that now. So this is probably going to be a pretty simple video, as it's not too complicated. Pretty much you can have any command, let's just keep it simple, ls, but it could be something way more complex. And we can redirect standard error with the 2 and the greater than sign, and we'll just call it error. Or, you might see error.txt or log.txt or whatever, it doesn't matter. We're just going to call it error. But you can also add another redirection in here for standard output, which is just the greater than sign by itself. And we'll just call that output. So when we do this, we can then go look into these files. We can look into the error file and see nothing because the command worked. And then we can go into the output file and see what happened. Now, this is going to replace this every single time. So if we issue this multiple times, well, it's just going to keep the same thing. You can, if you want, append, and the way you do that is you just use an extra greater than sign. So let's say we wanted to append all the errors, but we wanted to replace the output each execution. So in this situation, let's go ahead and issue a command that is going to throw an error. Let's try to ls in some folder that doesn't exist. Well, when we do this, we should be able to see that inside of the error directory. And if we issue that command again, well, it's going to now, gotta put the file name there, cat error, and you can see it now has 2 errors in there. You could do the appending for the output if you want. This is basically the way we have it now. It's going to replace that output every execution. So when we look at the output, it does not keep that previous output, it replaces it. Now the next thing I wanted to show you is that when we have a command such as this, the 2 refers to standard error. This is the file descriptor we've talked about in an earlier episode, and there's also 0 and 1, where 0 is input, which we're not using, and 1, which is standard output. And that's actually implied when you just have a greater than sign. There's an implied 1 here. So you could do this as well. That's going to work the same exact way, and we can actually issue a command that does work just to prove that. So we'll say ls, and then we'll take a look at output, and we can see those files there. So you might see 1s floating around whenever you're referencing stuff, but it's implied, so I'm going to leave that off of there. All right, cool. So that is how you split it out into 2 different files. So we have them going as 2 separate files, but now we need to learn how we can make them go to the same file. And it's a little bit more complicated than what you might assume, but it's not too bad. And I'm going to show 2 different ways of doing it. So I just decided to keep that in its own video. This video is pretty short, so sorry about that. But that's all we got for this one, so stay tuned for the next video. And we're going to learn about the final boss of redirection. And then we'll move on to something like pipes or something. Who knows? See you then. Stay tuned and subscribe. Welcome back, everyone. In this episode, we're going to learn how to redirect standard error and standard output to the same file. So you have some command. We'll just keep it simple and say ls. The way you're going to do this is you're going to direct standard output to some file. We'll just call it output. And then you're going to redirect standard error, and you're going to say ampersand 1. So we should be able to see the output there, and then let's say we have some error. We'll just say ls tacos, and we can see the error there as well. So this piece here at the end, 2 greater than ampersand 1, you can think of it as we're going to redirect standard error to standard output, which is already going to this output file. Now you might be wondering, what is this ampersand for? Well, if you didn't put that in there, it would look like you were just redirecting to a file called 1. So to be a little bit more specific and say, hey, no, we actually want to refer to standard output instead of a file called 1, then you would prefix this with the ampersand. So this is a pretty universal way of doing it. There is a better, easier way to do it, but it's not supported on all versions of Bash and older versions of Linux. So if you're on newer Linux, then you're probably fine, and I wouldn't even worry about this older version. But for those of you who might be doing some older stuff, then you might need to know this way of doing it. Now, you also probably see this in the wild, so it's probably good to understand what this is here. And here is a good Stack Overflow answer explaining this, so shout out to this person. At first, to redirect to 1 may look like a good way to redirect standard error to standard out. However, it will actually be interpreted as redirect standard error to a file named 1, and indicates that what follows and precedes is a file descriptor and not a file name. So the construct becomes 2 greater than ampersand 1. So yeah, pretty cryptic, kind of dumb, but let's talk about the better way of doing it now. Pretty much, you're going to issue your command and redirect and prefix that with the ampersand, and then give a file such as output. Is that simple? And now we can say cat output to see that output, and let's say we have some error. Well, now you can see it cannot access tacos. And if you want to append, it's very simple. You just add another greater than sign. So now you can see both of those errors exist. And if we happen to get one working, let's say we just issue ls by itself, well, that'll be appended there as well. So we got cannot access tacos, and then that output. So one of the downsides here is you can't append for errors and then replace for standard output. If you want to do that, then you'll want to do two separate files. If you want to do that, then we talked about that like 2 episodes ago. So if you want a good helpful table showing all these different options, you can find it on this question here. Scrolling down, you can see this lovely table of 10 different ways to redirect errors and standard output. And you can see them all here. We've pretty much covered some of these basic ones here. We haven't gotten into T. So if you want a good description of all these different options and how they differ, then this would be a good way to start. T is going to be used if you want that output to show up in the terminal, but also go to a file. We might get into that in an upcoming episode, but for now, we've got the basics of redirection down. You should be able to understand redirection to some extent when you see it in the wild, and you should be able to do it yourself if you want to basically clear out the terminal for cleanliness, or if you just want to keep a record of any issues that may have shown up for one of your commands or your scripts. So thank you for watching, and stay tuned for the upcoming episodes, and be sure to subscribe. Hit the like button. Hey everybody, welcome back. In the previous video, we talked about how to take the output of a program and put that in a file using redirection. Now what we're going to be doing is something similar, but it's a little bit different. So if you want to take the output of a program and use it as the input to another program, that's what this video is about. And that concept is known as piping. So you're going to use the pipe symbol, which you can find right above the enter key, right below the delete key on Mac. And here's what it's going to look like. So that is the symbol, and we're going to use that instead of the greater than symbol. So we'll start with just any command, and I'm just going to continue to use ls just because it's simple, and at this point, you know, it's one of the few commands that we really understand in a lot of detail. And what we can do is output some directory, such as /etc. So this is going to display a lot of directories and files. And based off of the previous video, we mentioned that we could redirect this to some file. We'll just call it files. And we can see that output by saying cat files, and it shows the same exact thing. Now we just lose the colors because we're just looking at the output of a text file. If you wanted to scroll through this giant list really nicely, you can use the less command. So you can say less files, and now we can scroll through this using the arrow keys, and then when we're done, we can hit the Q key. And that's going to bring us back to where we were. So it doesn't pollute our entire terminal, it just opens up a new application. The challenge here, or what the pipe can allow us to do here, is if we want that same behavior, but we don't want to have to save it to a file first. So we took our output of the program, saved it to a file, and then we used the less program to scroll through it. We can bypass that file by just doing the ls command, or whatever command it is, and piping it to the next command, which in this case is the less command. So here's what that's going to look like. We're going to say some command, and instead of redirecting to a file, which is what we did, we had files, we're going to just skip that process and pipe it to a new command, less. And now we get the same exact behavior where we can scroll through this, but we didn't have to use an intermediary file. That's just a really simple example, which is a great way to scroll through output of a command without having to create a file for just that purpose. So basically, this less command takes an input, but that input is being given by the output of this command here. So this allows us to create chains, and you'll often see long chains of numerous pipe commands in a row, where the output of one goes to the input of the next, and it goes down that chain to do some kind of processing. You can basically create a pipeline, take some input, do a bunch of transformations, and have some output. That's one use case of piping. So to summarize, for files, you do redirection. For programs, you do piping. Let's see a quick example of creating a chain. So we'll go with that same command, but before we pass it to less, what we're going to do is we're going to put another command in here, and we will use the sort program. And this is actually going to sort all of these lines. So when you look at this, all the ones that start with D are on top, and that actually means it's a directory. So we can go through here and see all the directories are on top, and then eventually we'll get to the files down here, which do not have the D at the beginning. So that is how you can sort an output. And let's go through a quick example of doing this with some more simple output. So we'll exit out of that, and what we're going to do is we're going to clear the screen, and what I want to do is say nano, and let's just create a file called names. So nano is a text editor that is inside of the terminal. You could also use something else if you prefer. We'll hit enter. Now yours will probably be empty. I was just testing this out. So what you want to do is just put a couple of names in here. We'll just say Caleb, Billy, Kara, and Sabrina. And the way you exit is Control X and then Y to save and then enter to save. So now when we say cat names, you can see we have Caleb, Billy, Kara, and Sabrina. Well, we could use that sort by saying cat name and then pipe this to sort. And names, cat names, and we have Billy, Caleb, Kara, Sabrina. There's a lot of other things we could do. So for an example, if you want to see how many names there are, you could say cat names, pipe this to a program word count, -L for lines, hit enter, and you get 4. Let's go through another example. Let's edit this file. We'll say nano names, and I want to add a title up here, students, and we'll exit by Control X, yes to save, enter for that file name. And now when we say cat names, well, we don't want to include this line here, so we can have a step in our pipeline to remove that. So before we get the sort here, what we could do is we could pass it to another program, which is tail, and we can remove the first line by saying -n +2. We're not going to get into all the details of tail. I'm just showing you a quick example, but that'll get rid of that first line. Now, this also shows the importance of ordering. If we were to switch this around, you're going to get a different result. So if we sort first, well, basically it's going to sort it and then remove the first one. So in this situation, Billy gets removed because that's the first one that comes in the list, and students stays here. So that's not what we want. We want to make sure we pipe it in the right order. So this one goes into this one, which goes into this one. There we go. So that's a quick introduction to piping. There's a ton of stuff you can do. This is just meant to be an introduction because we actually needed this skill to show what's coming up next, which is the T command. So if you remember from the previous video, we were talking about standard output and standard error, and I showed a table that showed the different options, and one of them had the command T. So if you want to understand what the T program does, well, you first need to understand a little bit about piping. So we got that down. Now we can learn about T. If you haven't watched the previous video and you want to know what I'm talking about, the table that I'm referring to can be found in this question: how do I save terminal output to a file? And it talks about all the different options down here in a table. We've talked about all of these here, and next up we have pipe T. So that's what we're going to talk about in the next episode, so stay tuned. If you enjoy this content, please be sure to hit like, subscribe, and most of all, I encourage you guys to have a good rest of your day. There's a lot of things to look forward to, including some frickin' sick videos, so stay tuned. See you then. Let me tell you what, I got some tea for you guys in this video. We're going to be learning how we can direct standard output, standard error to a file, but also direct it to the terminal. So that's what the T command does inside of Linux. So let's go through a few examples of how to use this command. Let's say we have some command, doesn't really matter what it is, where we list a bunch of files, and what we do is we add to this a pipe, and then the command T, which takes a file, so we'll say output, and we'll say .txt. And just to be clear, this is whatever you want it to be. I just add in the .txt here just so you guys don't get it confused with a command called output or something like that, because this might be a little bit more confusing, but whatever. You can name it whatever you want. You can call it tacos, doesn't matter. When we hit enter here, it's going to put all of the files inside of the terminal, one line after the other. However, if you now take a look at the output.txt file we created, it also has that content in the file. So this is useful if you want to output stuff in the terminal for maybe an interactive experience or for you to watch, but you also want to log that information to a file. That's where the T command comes in. And the reason it's called T is, if you think of a T, basically you have an input and then it splits that two different directions, one to a file, one to the terminal. So going off of the Wikipedia article on the T command, here is a beautiful visual that explains this. We have, oh, I guess the T direction is different here. Sorry, I'm not really a plumber, so I don't know how supposedly is based off the T splitter used in plumbing. So this guy right here. So basically we have an input and we have a file and then the terminal or the input of another command. They're using another pipe here, so that's why it says standard input. It's going as standard input into the less command. And we could do that same exact thing if we wanted. If we repeat this command and we pipe it to the less command, now we can see the output of what would go in the terminal, but it's in this nice, convenient less program. Awesome. So to make sure that's clear, we issue a command. It goes to a file, but it also goes to another destination, either the terminal, or if you pipe it to less, then it'll go in as the input to the less command for you to view. Or you could use it for some other command as well. Now when it comes to appending, if you're coming from redirection, you might just add another operator. So for example, if you say ls and you direct this to output.txt, if you want to append, you can just add another greater than sign. Well, pipes don't work that way. So what I mean is you can't just have a pipe t in output.txt, and if you want it to append to the file instead of overwriting it, you can't just add a second pipe here. That's actually something different, which we might talk about in the next video. So instead, what you need to do is you actually need to use the append option, which comes with the T command, which is -a. So in this situation, when we take a look at output.txt, you can see it actually appended those documents to that list. Whereas if you instead were to not use the -a, it's going to replace everything. And you see that there. All right, now let's clear the screen and go through another example. I want to show you another example, but first I want to compare to a previous example where we would have a command ls and we would put it into some file such as output, and we could take standard output and standard error by saying 2 greater than ampersand 1, which we learned about in a previous episode. So pretty much, no matter what, this is going to take the output and put it in that file, even if that directory doesn't exist. So we can take a look at that file, cat output, and you can see that's the error it gave. When we're dealing with standard output and standard error and you want to use T, it's a little bit different because by default, T only works with standard output. So if we said ls tacos and we said piped it to T output, well, we get an error and the error shows up in the terminal. It doesn't go into this output file. So the fix for this is right after the ls, we're going to redirect to greater than ampersand 1 and then pipe that to T. And now it shows up in the terminal and it should show up in output. Or if you're in a fairly recent version of bash, you can say something like ls tacos, pipe, and sign, T, output, and that'll do it. So yeah, that's a little complicated, but let's see what it looks like when we compare to that table we looked at earlier. In this table, we've talked about these in earlier videos, then we introduced T. Not so bad, but the issue here is that standard error does not show up in the file, as you can see by these two no's here. That newer version that we talked about, pipe ampersand, well, that's going to include standard error in the file. So we've talked about all of these and this one down here. The only one we haven't talked about is this here, which the only difference is that standard output doesn't show up in the file and standard error does, which takes a little bit more effort, and you can see a good solution here, which looks like this. But we're not going to do a dedicated video for that, so we're going to stop there. At this point, we've obnoxiously talked about redirecting and piping for pretty much every option for standard output and standard error. So I apologize if this has been like so much about one thing for the last 10 videos, but we've learned a lot of different things. There is a lot of different syntax to remember, and even I find myself mixing it up or having a reference, but that's okay. It's not the end of the world as long as you understand the concepts and you know how to figure it out. That's my justification for not having everything memorized. No, but thank you for watching. If you do want to see more, then stay tuned for the upcoming episode. Be sure to like and subscribe. We really appreciate you joining us for this journey. Hey, what's going on, everybody? Welcome back to the tutorial series. My name is Caleb, and we're going to begin starting to talk about administration inside of Linux, specifically talking about users, groups, and permissions. This is where you get to see some of the powerful parts of Linux and see some of the different capabilities. You see, Linux isn't just designed to be a single user system. You can actually have multiple users, and these multiple users can share files, and basically you can imagine an environment where you have one centralized Linux computer and numerous people connect to that computer at the same time and have the ability to share files between each other and protect their files from people who aren't supposed to see them. So there's all kinds of different permissions that come with Linux that you should learn about. So to start off, you should understand a little bit about groups. So you can say groups and it'll tell you what groups your user belongs to. And if you want to know who you are, the command is who am I. So we're on an account named Parallels, and that's because I'm using the Parallels software for this VM, and it defaults to Parallels. But for you, it might have been your name, or maybe something like student or something like that. And another command you should know is ID, and this gives a lot of other stuff, some numbers. And you can see in here we have UID equals 1000. That is your user ID. Then you have a GID or group ID, which is also 1000. And then we have groups with a bunch of different groups in here, which are the same as these ones here, but now it includes the ID of those groups as well. So we have 1000, 4, 24, 27, 30, 46, and 116. And all of these groups have some permissions around them. The ones that are most important are probably, starting off, the group that is your group ID. You can see it's right here. And then the next one is probably this pseudo group, which in this case is number 27. So when you're in the sudo group, you have elevated permissions when you use the command sudo. So if you can use sudo, that means you have the group sudo. Now when you say ID, it defaults to yourself, but if there's multiple users, you could go ahead and type in the name of that user, and that'll show you that user's permissions. If you're wondering, okay, well, how do I know what I can put here? Well, the easiest way, which takes advantage of the UI, is we could just log out. Yep, log out. And now we're given a login screen with the user parallels. If you had other users here, they would show up here. So we'll see that later on. And there's also the option to type in a username and password, so it might not list everybody, but that's a quick way on how you can see some other users. So where do these users come from? Well, they come from a database, which is a text file on this operating system that has a list of all of the users. So let's talk about how to find that. We'll go to the terminal and we're going to say get ent password with just WD. Hit enter, and here's a lot of information that can be a little overwhelming. If you scroll through here though, you should be able to find your user in here. And you can see mine is right here. So there's a lot of other users that aren't used to log in. They're not like a typical user. So how do we basically clear out this list to just get the typical users? Well, it's based off a convention. So if we look at our user account, it starts with 1000, and then the next user account is going to be 1001, and that number will just keep going up all the way up to 60,000. We can get a specific user by saying get ent password and then passing in their user ID. In this case, we'll use 1000, and that will just get my user account. If there were more accounts, you would just say 1001, 1002, and keep doing that all the way up to 60,000. So there's actually a shorter way of doing this, and we can expand these numbers out using curly braces, and inside of these curly braces, say your starting number, 1000, ... 60,000, and that's going to get all of the users between 1,000 and 60,000. Now this 1,000 here may not be the same for your operating system if you're not on Ubuntu, but say it's 500, you're going to do the same thing. You just might have to change the numbers a little bit. So we'll go back and we will add some users and see what happens when we issue this command. We should see those users show up. We're going to start fresh and we're going to say sudo add user, and we'll just call it student. Now for this, we will put in the password for our current account. So we will type that out. And I'll go through a process to add this user and create their home directory, home/student. Now we give this account a password. So this is what that user is going to use to log in. And there we go. Now you can go in and fill this info out. I'm just going to hit enter. Don't really think that's important. Yes. All right, so we created that user, and now we should be able to log into Ubuntu with that user. So we'll say switch user, and going into here now we have parallels and student. So they will have their own Ubuntu environment, just like switching users in Windows or Mac. However, we can also do it from the terminal. So I'm going to show you that process now. Inside of the terminal, we can use su, which means switch user or substitute user. And then we can say what account we want to switch to. So we will say su student, put in the password for the student account. And there we go. We are now on the student account logged in. So when we say who am I, it says student. Now you'll notice we're still in the home parallels directory, which is the home directory for the other user. So we could say cd to get back to our home directory. And now we're in home student. If you want to do that process automatically, when you switch users, put a hyphen before the name. So we'll say switch user hyphen parallels, put in the parallels password or whatever the user password is. And now it'll automatically change to the home directory for that account. All right, so now the command we issued earlier, ID, we can pass in the username student to get the information about that student. And you'll notice here that they're in a lot less groups. The user ID is 1001, the group ID is also 1001, and you'll notice that each new account gets a group of the same name as the user, but all those other groups do not exist here. So this account cannot use the sudo command, for example. And don't forget, we can see all of the users with getInt password 1000 ... 60,000. And there we go, we got parallels and student. Alright, hopefully that was a good introduction to users. In the next video, we're going to get a little bit more hands-on experience with groups, which are a very important part of Linux. Stay tuned, be sure to subscribe, and I'll see you then. Peace out. Hey everybody, welcome. In this episode, we're going to talk about groups inside of Linux. You might want to check out the previous video where we talked about the basics of users and groups. Now we're going to talk about how to create groups, add users to groups, etc. So the very first thing is you can type in groups to figure out what groups you are a part of. Or what you could do is you can say groups and pass in some username, such as student, and get the groups that this user is part of. So the student user is part of the student group. The same information will show up with ID with a little bit of extra information. So one group I wanted to talk about briefly and also to show how to add people to groups is this pseudo group here. This is needed if you want to do something that requires elevated permissions. So for example, let's switch over to an account that does not have elevated permissions. So we'll say su-student, put in the student password. And what we want to do now is we want to say sudo add user test. Put in the password, and it says student is not in the sudoers file. This incident will be reported. Aw, snap. He just got reported. So what we can do is we can issue the command, which we'll have to do it from an elevated account, but we can say sudo usermod -a capital G, and we're going to add the sudo group to the account student. So this is the command, and again, it's going to give us the same problem. Student is not in the sudoers file. So anytime we prefix something with sudo, it's not going to work. So let's go ahead and switch over to the other account, parallels. All right, and now let's issue that command again. So we will oh, this is a good point. If you see me scroll up, you'll notice that the command history is different. So the command history is per user. So I can't just scroll up and grab that previous command we tried to execute, which was up here. So what I'll do is I'll just copy this and paste it down here. And there we go. Now what we should do is say groups student, and we can see that they are part of the student and the sudo group. So we can also say man user mod to get a little bit more information about those options. So we have append to add the user to a group. And then there's two options in here that we want to know about, which is lowercase g right here and uppercase G. You use the uppercase G if you want to add them to a group, or you use lowercase if you want to change their primary group. So what does that look like? Again, if you say ID, it's this group right here. By default, it's just the same as the user account. But for example, you could have a group that is for all students and then they all join that as their primary group. So we used lowercase a, uppercase g because we wanted to add a group to the group list, but it's good to know about the lowercase g as well. Now when you have files, they're going to be owned by a user and belong to a group. So you can see that information with the -l on ls. Hit enter and we get a little bit extra information. You see we have parallels on here twice for each one of these directories. This first on here is the user owner, and then the second on here is the group. Our username, which has the value parallels, is the same value used for our primary group, parallels. So this is the owner, and then the group it belongs to is also called parallels. Another option is to say ls-g, which will remove the owner and just show the group if that's what you're focused on. So to go through a quick example, I want to show a file owned by somebody else. Right now everything here is owned by parallels and is in the parallels group. So to do this, what I want to do is I want to take a look at home, and in here we have this student directory, which right now is empty. There's nothing in there. So what I want to do is I want to touch a file in home student, and we'll just call this test. And this is going to require sudo because we are putting this inside of someone else's home directory. So we'll do that. And now what I want to do is I want to switch users over to the student account. And we say ls, we see test here. If we go ahead and create a file ourselves, we'll just call it something like assignment. Now when we say ls-l, you can see we have one created by student in the student group, one created by root in the root group. And that's because we used sudo, so it went up to root when we created that file right here. I'll show you another example where it doesn't show root here, but actually another user besides root. And for this, we're going to actually change some file permissions. We're going to talk about what this command does here soon, but we'll just change this directory. So basically, we're giving full access to everybody to the current directory. So let's switch users back over to parallels, to the main user. And we're going to touch another file. This time we don't have to use sudo because we have permission. So we'll go into student and we will just call this test2. And now when we take a look at /home/student, you can see there are 3 files, one created by the student, one created by root, and one created by parallels. All right, we'll probably look back more at this here soon, but for now I wanted to talk about how to add a group. So what we're going to do is we're going to say sudo group add, and then we'll just give it a name like students. So this is where all the students can belong in this group, and we can add this to our student account. This is what it's going to look like. We're going to add the student to the students group. Now, this might be kind of a silly example, but basically you can imagine instead of having a student account, you would have an account for each student. So maybe one for Caleb, one for Sally, one for Sarah, and all of them get added to the students group. So whenever you would say group and pass in some user, well, my bad, groups, well, then it's going to show that they are part of the students group. Every single student can be added to this group. And just to show you, here's how to change the primary group. Sudo user mod -g students student. Basically, we're going to drop the -ag and just use lowercase g. And now when we say ID student, you can see their primary group is now students. So you can use these tools to basically give permissions that apply to a group of users. So let's say all of the students should have access to the homework folder, or maybe they all upload their homework to a specific folder, and that's shared within the group. That's just an example of what you can do with these groups here. So earlier on we used this command, it was chmod. What we're going to do in the next video is we're going to introduce that command and talk about how it works. So stay tuned for that. It's going to be a pretty cool video. Hey, what's going on everybody? In this episode, I'm going to help you understand the chmod command, or chmod, and we're going to figure out what the file permissions are, how to change file permissions, and how to understand the octal that is often used with this command. It could be a little confusing at first, but I actually think this is a much easier way of doing things than the way you'll often see, which I'll show you guys probably in the next episode. So basically, here's what's going to happen. When you list the contents of a directory, you get all this junk over here on the side. So if it starts with a D, it's a directory, and then you have these permissions. So read is R, write is W, and X is execute. So we have read, write, execute, read, write, execute, read, write, execute. What in the world? Why is there 3 of the same thing? Well, there's actually 3 groups here. This one refers to permissions for the file owner, or in this case, student. This group here, refers to permissions to the group, anyone in the students group. And then this one here is everybody else. So in the context of directories, what does an X mean? How do you execute a directory? Well, it just allows you to enter that directory. So let's go ahead and change directories. So now we are in our home directory, and we can say ls, still a bunch of directories. So actually, let's create a file. And now we have one file created, and we'll say ls-l. And now it looks a little bit different. We have some more options on here, and you can see this one is the file. First thing you'll notice is it starts with a dash. So a dash is a file, a D is a directory. We can change these permissions by saying chmod and passing in some number. So we'll talk about how you figure out what this number is, but let's just go through an example of opening the permissions as much as possible. Basically, anybody can do anything they want with this file. So we will say chmod 777 file. Now when we say ls-l, and we can actually pass in the name of that file, you can see these are the permissions now. Read, write, execute, read, write, execute, read, write, execute. So let's talk a little bit about these numbers here. Each 7 refers to a group. So just like these 3 here refer to a group, these 3, and then these 3, each one of these 7s assign values to each one of these groups. So RWX can be represented with the number 7. So we have 7, 7, 7. So 7 is the highest permissions. All right, now I'm going to talk a little bit about how you can choose what number you want there. And this can be a little confusing at first, so pay attention, but it's definitely going to make sense if you watch this enough times. So inside of a group, we have read, write, execute. Each one of these has a value. So X is 1, W is 2, and R is 4. If you add up 1, 2, and 4, what do you get? You get 7. So let me zoom in here a little bit, and we'll go through this one more time. X is 1, W is 2, R is 4. You add them up, and you get 7. So let's talk about what if you did chmod 666 file. Let's try that. And then we'll say ls-l file. Now we have rw-rw-rw-. So basically we subtracted 1, which removed that 1 value. So let's try another one, and I'll see if you can guess what is going to happen. If we say chmod 444 file. Think about which position has the value 4 and what the final result's going to be. And we'll check it now. You can see it's read, read, read. That's because the read has a value of 4. So we got rid of the 2 and the 1. So what if you wanted it to be read and execute? Well, it would be 4 plus 1. So we would say chmod 555, and there we got read and execute, read and execute, read and execute. So as you can tell, each number that you can use has an associated permission. 7 is full access, 4 is read only, 5 is read and execute. So now you have a basic understanding of how that works. Let's take a look at a table that shows all the different options. Here is an article from Linode listing out these options. So 0 is nothing, 1 is execute, 2 is write, and then when you go to 3, you basically add those 2 together to get write and execute. 4 is read, 5 is read and execute, 6 is read and write, and then 7 is read, write, execute. So another way you often see this visualized is with binary. So obviously each one of these values, read, write, and execute, can either be on or off, and that could be represented with a 0 or a 1. So if you take a look at this one, for example, we got execute, write is skipped, and then we have read. So we have 1 for on, 0, and then 1. So you can see that matches the same pattern where 1 is a value and 0 is a dash. And then if you pretty much take this value in binary and convert it to octal or decimal, we get the value 5. Now when we've been given these permissions, we've been doing them in group of 3, 7, 7, 7, for example. However, you don't have to do all the same. You can split it out into different groups. We can use different values for each group. So let's take an example where instead of doing 3 of the same numbers, we actually do 5, 6, 7. Now when we take a look at this file, the first is read and execute, the next is read and write, and then the next is read, write, execute. Alright, so now that you have a pretty decent understanding of this command, let's go through an example. And what I want to do is I want to switch user over to our student user, which we created in, I think, the previous episode or the video before that. And we'll take a look at the files in here. We have this assignment here. What we could do is we could change the permission on this, and let's just get a clean slate real quick. So we're going to say chmod, and let's say we only want this to be able to be seen by other students and ourselves. So our username is student, but we're part of a group called students. So this section here refers to ourself, read and write, that's good. This next section is our group, the group, which is students, read and write, that's good. And then if we want to prevent anyone else from seeing it, all we would do is remove this permission. So we're going to say 660 assignment. And I got 6 because 4 plus 2, 4 plus 2. And then 0 to remove all of these. Hit enter. Now ls-l. And we can see we removed that read permission for everybody else. So when we are on another user, we'll see if we can go see that file. We'll say cat home student. We can see the assignment file exists, which I literally didn't even spell that right. I'm so dumb. All right, we're going to type that out. Hit enter. And it says permission denied. So in order to see this, well, we need to either be sudo or be in the students group. So let's add ourselves to the student group, sudo usermod ag students, and we'll just put ourselves here. All right, and now let's reissue this command. And I think we need to refresh here, so we'll just re-log in. And now let's say that command again. All right, and there we go. We did not get permission denied. Obviously, there's nothing in that file, so nothing shows up, but it is working. We could also show an example where we remove access for the group as well. So let's just do that with a sudo command to make it easier. And we'll say chmod 600 and then home student assignment. All right. And then we'll list those files. So ls-l /home student. We see we can only read and write if we are the owner, which is this first group here, which the owner is student. We are not student, as you can see. So we shouldn't be able to access that file at all. Let's see. And you can see it says permission denied. All right, wow, that was a lot. If the use of octal, the values 0 through 7, didn't really settle with you well, there's another way that you can work with permissions, and that's what we're going to take a look at in the next episode. It's probably important that you understand both ways of working with these files. Hey everyone, welcome back. We're going to continue our discussion on file permissions in Linux. It's so fun. In the previous video, we talked about chmod, and we're going to continue to use that command in this video, but we're going to change it just a little bit because instead of using octal, we're going to be using a different notation. And this book I've been reading, the Linux command line, has some good like tables and stuff, and I was like, man, I wish there was a way I could show you guys these tables. Well, I actually managed to find these exact tables online, and they gave credit. So pretty much we're working with these different permission setups, and so far we've done the octal numbers to get the different file modes. However, there's another notation where instead you can specify what permissions you want to add or subtract. So X being execute, and then U being the user. So if you wanted to add the execute permission to the user, you would say U plus X. So overall, there's 4 different symbols: U for user, G for group, and O for everyone else. And then if you want everybody, you would use an A or all. So you can add execute, you can subtract execute, or you can be specific and say exactly what permissions you want using assignment. So if you wanted to assign the read and write permission to the group and everyone else, this is how you would do that. So let's go through some simple examples of this. Open up the terminal. And right now we have no files. Let's just create a file. We'll just literally call it file. And now let's take a look at the default permissions. We got the hyphen here for saying it's a file, read write for the owner, read write for the group, and then read for everyone else. We can say chmod. If we want to give write permission to everybody, we could say O for other plus W for write, and then the name of the file, which in this case is just file. And then let's take a look now. You can see we added that permission. So it's pretty simple. Let's go through an example where we want to specify the permissions. If you wanted to give full permission to everybody, you would say chmod A plus read write execute file ls-l, and you can see we have full permissions for everybody now, which in general is not really recommended, but just showing you that it's possible. Let's go ahead and assign some new permissions. So we'll say chmod A equals read and write, and that'll get rid of the execute permission, but everybody is still read and write. We haven't really talked about what the X means, but basically it allows a file to be executed as if it's a program. We might see that more coming up. All right, let's clear the screen, and now I want to give it a possible challenge and see if you guys can write the exact command to make it work. So let's say we want to give read and write and execute permissions to the owner, read and write to the group, and then just read to everyone else. What would that command look like? And keep in mind, when you have multiple users like that, you can separate them here with a comma. All right, so now let's go through what that would look like. We would say, first let's just get a list of the files, chmod. So for you, that's how I remember. I literally think of it like you as in yourself. We can assign the value read, write, execute. For the group, we can say read, write. And then for other, we can just say read. And then the file name, I actually think this is an issue with spaces being after the commas, which is interesting. So sorry about that, but let's check this and see if we got what we were expecting. Read, write, execute for the owner, read and write for the group, and read for everyone else. So that is an introduction to chmod with symbolic notation. And another little bonus here with this question, understanding chmod. Well, there's a link down here to actually get the book as a PDF version, which I don't exactly know how that works from a copyright point of view. I don't know if it's like legal, but yeah, here's the thing. I'm assuming that the author put this on here. So, and there we go. So you can find this information around page 90, and you can get all the details. So thank you, Mr. Schatz, for putting your book out there for everyone to view. It's really helpful for the series, and hopefully it wasn't pirated. I'm pretty sure you put it on there, though, because that is, in fact, your username here. Thank you for watching. Stay tuned for the next video. Peace out. Hey, what's going on, everybody? Hope you're having a lovely day. Today we're going to talk about the command chown. And if you don't pay attention, you're going to be chowned. So turn on that little brain of yours, because this is the command used to change ownership of files. So we're going to use this command to get some practice with shared directories. So let's go ahead and create a directory in the home directory, and we'll just call this students. So this is going to be a shared directory for all student accounts to have access to assignments or whatever it might be. So we can change into the students directory, and we can touch a file here. We'll just say assignment1, and we might need to prefix this with sudo, and that is based off of the permissions of the /home directory. And you can do ls-la to see the home directory right here, the permissions, there's not write permissions given to other, so you have to do it as root to get the read, write, and execute permission for anything inside this directory. But anyways, that's why we're prefixing things with sudo. So when you see we have assignment 1, you can see the owner, which is root and root. Well, we might want to change this group from root to something else, such as students, which we created a group of students earlier, which we added to this user students. But if you need to create a group, you can say sudo group add students, and that'll get you that group. So to assign this students group as the group owner for this file assignment 1, what we will do is we will say sudo chown or Chown, however you want to pronounce this. And there's 2 parts to this. So you're going to separate the 2 parts with a colon, the left side being the owner or the user account, and the right side being the group owner. So we're going to change the group, so we're just going to use the right side, and we're going to say students, and then the file we want to change, which is assignment 1. Now when we say ls-l, you can see the owner is root, and the group owner is students. So when you look at these permissions, the root user can read and write, and then anybody inside of the students group can read. And let's say we wanted to remove the permissions from everyone else, we can do that now. So we'll say sudo chmod other -read assignment 1, and now you can see only the owner can read and write, and the group can read. So let's try this out. We're going to switch users to another user, which is called student, which I created this earlier. Again, if you need to create that, you can say sudo user add student, and you can see it says student already exists. So let's go ahead and switch that user using switch user -student. And if you wanted to stay in the same directory, you can just get rid of that hyphen. So we're still in the students, and we should be able to still see that file here, and we can say less assignment 1, and you can see what's inside of it, which is currently nothing. We can also use chown to change the file owners. Right now the file we have is owned by root. Let's go ahead and change it from root to our main account. So you can kind of think of it as an environment where you have students and then a main teacher which manages the whole system. Let's take a look at our files real quick. We have this one file owned by root. We'll say sudo chown. We're going to change the owner to our main account, whatever your account name is, and then the file, which is assignment 1. Hit enter, and now you can see it's owned by parallels and students. So let's go ahead and switch user over to our other account. And from here, what I want to do is I want to echo tons of homework into the file assignment 1. We don't have to do anything like sudo or anything fancy, and you can see our permissions allow us to read and write, and we are the file owner, so we're good. So now we can say less assignment 1, and we can see all of the content of that file. And if we were to switch over to the student account, we're not able to issue any commands to modify this file. So let's say we said no homework. This is just not going to work. Permission denied. Now, obviously, right now, the students has the sudo group, which you're not going to want to leave that on for all your students to use. So obviously, you can set up these permissions however you like. You can use owners and groups such that you could have a system where all the students can view the files created by the teacher. The teacher is the owner, so they can modify it. Then students can create their own files, which other students cannot modify, and the owner of that file, which is them, can edit it. So that's like an example environment you could set up. So that is your introduction to the chown command. Obviously lots you can do with this. This is just supposed to be an introduction. So hopefully it was a good start and can get you set up and going for whatever assignment you have. Thank you. Stay tuned for the next episode. Peace out. Hey everyone, welcome. In this episode, we're going to talk about the Umask command inside of Linux, as well as some special file permissions. So starting with Umask, this is used to define the default file permissions. So when we are in a directory, we can create a file, and we can see the permissions with ls-l, and then put the file name, and you can see that's what they are. Now we can do a similar thing for a directory, so we'll say mkdir, and I don't know, I'll just call it files. I literally can't think of anything. Now if you want to see the permissions of this, you don't say ls-l files, because that's actually going to see what's inside of the files directory. Instead, you want to say ls-l dot for the current directory, or just leave that dot off of there because it's implied. So that's going to show everything including the files directory here. So here are the default permissions for a directory. So how do you see what these default permissions are, or how do you quantify it, I guess? Well, you can type Umask and you get a number, in this case 0002. This is a representation of those default permissions. So when we take a look at that file again, how does this number give us this value? Well, if you remember when we were talking about the chmod command, we talked about how each position had some value and you could represent it with Octal. Well, it's a similar thing here where this has the value 1, this has the value 2, and this has the value 4. So all of them together is 7. And pretty much what this mask is going to do is it's going to grab the position 2, and any position that it hits, it's going to remove those permissions. So it's going to remove the right permission here. So you can change the Umask by saying Umask, and we'll just go with 0000, and we'll talk about why there's 4 here in a moment. You might be used to seeing 3 with chmod. And now let's create another file. We'll say file2, ls-l file2, and you can see we now have read and write permissions on all of them. That's because the Umask, or the default permissions, are 0. So we're not going to remove any of the read or write permissions. So you can think about if we have no Umask and we don't mess with anything, then the permissions are going to be read and write for user, group, and everyone. If we want to change that, that's where the Umask comes in, which will change the default. And now let's talk about how we can change these numbers to get different permissions. So let's say we wanted to get rid of the read permission for each one of these. Well, it would look like this. We would say Umask, and you start with a 0, and then the read permissions have the value 4. So we'd say 0444, and then let's just try this out. We'll say touch file 3, ls-l file 3, and you can see we got rid of value 4, 4, and 4. Comparing that to the other files, we had these before, so we got rid of R, and R, and we're just left with the right permissions. If you wanted to default with no permissions, you would say Umask 0777, which would remove any permissions. And we'll try this out. Touch file 4, ls-l, and you can see the progression here. So now we have no permissions at all. Another way we can think about this is actually work with binary, which might be a little bit more visual. It does the same thing, works the same way, but instead of thinking 1, 2, and 4 and all these weird values, you can actually write out the number in binary, and anywhere there's a 1, a permission will be removed. So let's take a look at it. Well, first, let's go ahead and change Umask back to the default 0002. All right, perfect. So when we create a file, it looks like this on the permissions. And each permission here can be represented as a 1 or a 0. And we can think about them in groups of 3. So we'll start with this group here. You could represent that as 1, 1, 0. This next group, similar thing, 1, 1, 0. And then this final group here, which now that I think about it is kind of confusing because this is actually the permissions for the group. So maybe calling these groups is a little confusing. But this next section here would be 1, 0, 0. So these are our permissions. And then if we created a Umask, we can remove any of these permissions by using the value 1. So let's say we wanted to remove the read permission, we would say 1. If we wanted to keep these the same, which you don't have to worry about execute in this case, you would just say 0, 0. And let's say for the next one, we wanted to remove the write permission, but keep read. So we would say 0, 1, 0. And then for this last one, let's go ahead and remove the read permission 1, 0, 0. So basically you're going to take this value, pass it through this value, and anywhere these ones clash, you're going to remove those permissions. But you're still going to use the same exact Umask syntax, but you're going to just take these values and convert them to decimal. So you can do that with any online converter. So you can take your value, and I'm just literally just looked up binary to decimal converter. You can enter a binary value, convert, and that's where you get that number 4 from. So our command would be umask, start with a 0 because it's a 4-digit number, and then we would say 4. For this next one, we would take 0, 1, 0, copy that, paste that here, get the value 2. And this next one, we'll take 1, 0, 0, convert that, and we get the value 4. So this would be the Umask to change the default permissions, and this only affects new files, so touch file 6, ls-l file 6, and there you go. So we got rid of the read, and we got rid of the write. And a similar thing can work with directories too, so if you want to try that out, you can. Now, the next question is, why is this a group of 4? Well, file permissions are actually in groups of 4. When you use chmod, when we say something like chmod 777 or whatever, well, you can actually put another number on the left here that can mean something else. And these are special file permissions. Now, I'm fairly new to these. I haven't really used them a whole lot, so I'm just going to give you an introduction. And then if you feel like, oh, hey, that's something that would be useful to me, you can do the extra research, but this will just get you started. So basically, there's 3 special file permissions, and you can use them by using the value 1, 2, or 4. 1 is called the sticky bit, 2 is called the setGID bit, and then 4 is called the setUID bit. SetUID can be used with scripts to allow them to access pseudo privileges. SetGroupID will give files within a directory the group owner of the directory rather than the group owner of the creator of the file. So that's a little confusing, but I'll show you an example of that. And StickyBit allows you to control the deletion of files inside of directories. So if we create a directory, we'll just call it test, and we say chmod, and just for simplicity's sake, I'm going to give full permissions to this directory, and we'll just say test there. I'm going to change directory into test, and I'm going to create a test file 1, and now I'm going to switch user over to another user, and I'm going to create test file 2. Now when we say ls-l, we can see the permissions for these files as well as the owners. So here is the first file we created, and then here is the second file we created. If we now take a look at the file permissions inside of the parent directory, we can see the test directory down here and the group owner of parallels. We can use the setGroupID so that any files created inside of this directory will always have the group ID parallels instead of, in this case, it has the value students. So I'll show you how to do that. Let's just clear the screen to get a clean slate. Plus then if I screw anything up, I can make it look like I edited it and it was perfect. And what we're going to do is we're going to say chmod. I'll keep the same file permissions in this case, but now we are going to add another number here, which is the value 2. And we're going to change the current directory. We will need to prefix this with sudo. And now when we take a look at the file permissions, let's go ahead and create a new file. We'll say touch test file 3 and then ls-l. You can see the group owner is parallels. And where can you visualize this? Well, we can get the file permissions of the parent directory, and you can see inside a test we have this new permission here, which is an S. So that is an example of how to use the setGroupID. If you want some extra research, you can look up how to work with the setUserID as well as the sticky bit. So again, I just wanted to show you the basics of that. I haven't really used these much beyond this video, but I just wanted to introduce that concept in case you needed it for future stuff. It could be handy if you pretty much want a directory that always has the same group owner, which might come in handy if you're trying to do some group work and you want all the files in there to have the same permissions for a specific group. So that was a lot in this episode. Hopefully it was helpful with something. A little bit more wordy and detailed than the previous episodes, so hopefully I didn't lose you. Thank you for watching so much. Stay tuned for the episodes in the future. I'll see you in the next one. Peace out. Hey everybody, welcome. In this episode, we're going to talk about how to issue multiple commands inside of the terminal, as well as some different operators you're going to run into in Linux. These are going to come up in the upcoming episodes, so I figured I'd just do a video to talk about them specifically. So for example, what happens when you have an and sign? What about two and signs? What about a semicolon? What about two pipes? What do all of these symbols mean? That's what we're going to get into in this video. So if you've been following along, we're pretty much just going to start with a clean slate. I'm going to remove everything from the working directory. Alright, so from here, we're going to first talk about the semicolon. This is used to separate multiple commands. So the easiest way to see this is to put a sleep on one side and then some command on the other, such as this. When I hit enter, nothing happens for 5 seconds, and then the words hello world will show up on the screen. So pretty much this command happened first, and this happens synchronously, which means one after the other. Once this command finishes, this command is issued, which will echo hello world to the terminal. Next up, I wanted to talk about a single and sign, or an ampersand. This is going to execute some command in the background. To show you this, I actually want to create a script real quick that we can execute in the background. So I'm going to do this by saying echo, and what goes inside of these single quotes is what's going to go inside of the script. You can also just open a text editor, but why not just make it more difficult on yourself and do it all in one command? So we'll just say echo. So our script is actually going to echo as well. So hello world inside of double quotes, and we're going to direct this entire thing into a file called script. So pretty much we're going to take this and echo it into a file called script. That's why there are two echoes here. So when I press enter, I can say cat script to see the content, and it says echo hello world. So if we execute this as a script, basically this will be interpreted as a bash command. So to do this, what we will do is we will say // and then the name of the file, script, which will almost work, but not quite. You see, it says permission denied. And when we say ls-l script, you can see that's where this comes in. This dash we haven't really talked a whole lot about is executing the file. So if we wanted to add that permission, we can say chmod plus x, which will add the execute permission for everybody, and then just put the file name. And now you should see read write execute, execute, and execute. So now when we issue that command from earlier, // script, it's actually going to execute the file and put the output of the script in the terminal. You can see that's different than this. This is the command that's actually executed, and this is the result. So that's how you can create a script. Obviously you could edit it with nano as well. So we could say nano script, and you could go in here and add commands. So for example, we could say sleep 10, control X to exit, yes to save, enter for the name. And now when we issue that same command to execute the script, it's going to wait 10 seconds and then say hello world. So now we have a script that takes 10 seconds to run. So this is where we can practice running something in the background. We can use the and sign to say, hey, run this script in the background and let me do something in the meantime. So we don't just sit there waiting for 10 seconds. And this is a fairly fast script. What if we had one that was doing a bunch of stuff? We can say // script and sign, hit enter. That's going to run in the background, and then we can do other stuff in the meantime. So I can issue this command, and eventually that original one is going to finish, hello world, and you can see it finished here. When you use the single and sign, it goes to the background. You can see the processes in the background by saying jobs, and you can see it running right there. You can bring it to the foreground with FG, and now it's waiting and it finishes. You can use the single and sign followed by another command, such as this. In this situation, the script is going to execute in the background, and then we're going to echo some string here. When we hit enter, we get that output immediately, hello first, and then the background task is going to execute. It takes 10 seconds, and eventually that output's going to show here. So that is how you can issue an asynchronous task in the background while you do something else. Another thing you're going to commonly see is two and signs, and this will basically execute these tasks synchronously, so it's going to wait for that first one to finish and then execute the second one. This is different than the semicolon because it's only going to execute the second one if the first one doesn't error out. So let's take a look at an example. Let's first just do it normally. So we'll just add another and sign here, hit enter. It's going to wait 10 seconds, finish the background script, and then it's going to echo this command here, which is no longer going to be first, it's going to be second. So it's a little confusing with the words there. Maybe I should fix that, but I think you guys understand. Basically, this script executes first and we wait for it to finish because we have two and signs. This is going to be the exact same behavior as the semicolon. And there you go, you can see we get the same output. The difference here is with the two and signs, if this threw an error, then it's not going to issue this second command. Obviously, script is very vague and a lot of different things could happen in that. So with whatever example you're working with, there's a big chance an error could be thrown. An easy way to see this is to just use a command you know is going to throw an error, such as if you try to explore a directory that doesn't exist. We'll just say not a thing. This is going to give us an error, right? So if we said that with two and signs, and then something like echo found the directory, well, here's what happens. It says cannot access not a thing, and this echo never executes. If instead we decided to use a semicolon, such as right here, it's going to do that second command no matter what. So I'll show you an example of that. This shows no matter what. And we will replace the and signs with a semicolon. Hit enter, and then you can see that output down here. So far so good. We've talked about the semicolon, the and sign, and the double and sign. Now another one, which I actually briefly mentioned in a previous video when we were talking about pipes, you might see two pipes in a row. And this is actually not used for piping, rather it's used in a similar nature to what we're doing here, where we want some command to conditionally execute. So it's going to look something like this, where we have some command, and then two pipe symbols, and then some other command. And this is going to work very similar to the and signs, but the difference here is that this is an or operator instead of an and operator. And in this situation, it's one or the other. So if this command executes successfully, then there will be no execution of echo hello world. So basically, if it does fail, then this second command will be executed. When we hit enter, this echo is not going to be executed because the script doesn't error out, so we just get the output of that script. If we do what we did earlier, where we try to list the contents of a directory that doesn't exist, or we issue another command, in this situation, the echo will only show up if this errors out. In this case, it does, it says failed. So they're pretty much opposites. You can take a look at this line here. The second command will execute if the first one is successful. For this one, the second command will execute if the first command fails. So do this or this. So altogether, we learned some pretty good operators. These are known as control operators, and there are other ones out there. This is the basics, and we might come back and look at some other ones, but this is what we're going to be needing for the upcoming episodes. So hopefully that was helpful and gave you a pretty decent understanding. These same symbols can be used for conditionals when we get to bash scripting. If you want to check the value of something or branch like an if statement or a while loop, these symbols are going to show up again. If you come from other programming languages, you're probably familiar with that. Stay tuned for the upcoming episodes. In the next video, we're probably going to talk about how to install software on Linux. So that'll be pretty fun. It'll allow you to explore different software out there. Thank you, and I'll see you in the next one. And subscribe. Hey, what's going on, everybody? In this episode, we're going to learn how to download software on Ubuntu using a package manager. Now, if you're on another Linux distribution, say Red Hat, it's going to be different. So you'll either need to stop using Red Hat and use Ubuntu for this video, or figure out the equivalent commands for Red Hat. Why is this exactly? Well, Red Hat uses yum and Ubuntu uses apt, I just call it apt, which is Advanced Package tool. And these are both package managers just for different distributions. So we're going to stick with apt-get for this video. So basically here's the command to install different software. So pretty much anything you'd ever possibly want in life is already made, and you can find this through a package system such as apt-get. You can look through available packages by going to packages.ubuntu.com, and here you're going to be able to search for anything you'd want, such as YouTube download. Now pay attention for this box here. If you want to go by package name or description, we're going to go by description here. We'll hit search, and here are the different packages available, such as this one, which is what I was thinking of. But I'm going to be showing you how to do all of this from the command line, so we can go ahead and switch over to that now. So here we are inside of the terminal, and the very first thing you'll want to do is issue two commands. So we'll say sudo apt-get update and sudo apt-upgrade. And then if we're prompted with any questions, we can hit yes by passing in an option here, -yes. So this is basically an all-in-one command to get you fully up to date with any packages out there. So we'll hit enter, put in your password, and this is going to take forever. It also depends on your internet speed. So there's two parts. There's updating packages and upgrading packages. Updating will basically get the most up-to-date available packages, and then upgrading will actually install all the latest updates. So you update first to get the latest repository, and then you upgrade to install all of those changes. So basically when you have a fresh install of Ubuntu, you'll probably want to issue these commands so that you have everything up to date. And I've had this impact me before where I'm trying to install some software, wasn't quite working right because I didn't issue these commands. So when you are done with that, and you issue some command that you would expect to work, maybe from prior experience, for example, type vim, well, it says command vim not found, but can be installed with, and it gives some options. So this is telling you how to install the software using apt. You basically say sudo apt install, and then the name of whatever you're trying to install. So we can say sudo apt install vim, and vim is just an example software. You might want something else out there, but that's going to install it as well as any dependencies or other software it needs to run. Now when we say vim, you can see something happens, and this is just a text-based editor. So I got to remember how to get out of here. :q. There we go. So now what we can do is we can list all of our installed packages by saying dpkg-l, and that's going to list out our packages. This is an interesting table where you can use the arrow keys to scroll over. And you can scroll through here. Got a lot of stuff installed. And eventually, after scrolling enough, you can see Vim is right here. That can take forever, so if you want to specifically check if something is installed, you can use the S option. So dpkg-s vim, and it'll give you the information about that package. If you put something that isn't there, here's what's going to happen. So how do we see what software is out there? We say apt cache search and then some name or description. YouTube download, for example. Hit enter, and it gives us a list of options that might fit our description. So for example, this one here, YouTube DL. So that's how you could figure out what the name is. And then you would just say sudo apt-get YouTube DL. And do not forget the install keyword. There we go. Yes, we want to continue. And this is specific to this software, but once you have that installed, you should be able to use the command youtube.dl and pass in a URL. So we'll say youtube.dl, grab some URL from YouTube, paste that there, hit enter, and it broke. Well, I guess that installation didn't go as I planned. However, this does bring us to an interesting point where you can install software manually using a download from the internet. So in this software's case, the installation through the package manager didn't quite work, so we can actually get a .deb file, Debian, which Ubuntu is based off of, from the internet and install it manually. So here's the webpage for YouTube DL at packages.debian.org, which you can just download one of these and save file. When you do this, it might warn about it being a security risk, which you can just click allow download. Once that's downloaded, that'll show up in your downloads folder right here. And now let's figure out how to install from a .deb file. So let's go to the terminal. We'll say sudo apt install /downloads and then the name of that file. Hit enter and that will install the software. And now let's try it again, YouTube DL, and we'll paste some address in here. Paste, and that'll start downloading the video. All right, that just downloaded, and I think we should be able to go see this somewhere. Videos maybe? Where does it go? Ah, there we go, in home, here is the video. All right, there we go. Honestly, we should probably try to download VLC. We'll see if that works. VLC followed by the file name. And there we go. This is a really good open source video player. Another cool one is GIMP, which is a photo editor. Sudo apt install GIMP. And we'll see if this works. And there we go. You can edit all kinds of photos in here. And pretty much, like I said earlier, there is an unlimited amount of software out there that you can try, and it's really easy to install and use. So thank you for watching. Hopefully this video was helpful. Stay tuned for the next one. Peace out. Subscribe. Hey everyone, what's going on? Are you having a good day? I sure hope you are. Especially now that you're watching this video, your day better get a lot better, because we're going to be continuing our discussion on processes inside of Linux. I think the video before the last video, we talked about control operators and how to run processes in the background, and we kind of introduced the idea of processes. But now I want to talk a little bit more about how we can view these processes and control them. We'll start with a quick review showing that you can run something in the background by using the ampersand or the and sign. And when we hit enter, well, it looks like nothing happens. We just get this weird number going on here. What is this? And then eventually we get an output, hello world. And that's just based off of the content of the script. So if we say less script or cat script, you can see echo hello world after it sleeps for 10 seconds. Well, you can get a visual of this by saying PS, and this is going to list your processes. So if we reissue that same command, /script and sign, and then say PS, we can see a few things going on. We have that sleep command running, another instance of bash, and of course PS, which is the command we're issuing right now. Now that it's done, when we say PS, we don't see those extra entries in our process list. So we saw this output in an earlier video, but we never really talked about it. So we have 75628. Well, this is the process ID. So when you get a list of all the processes, you can see what it's talking about, 75628. This is a new instance of bash. And then every new command we issue, such as sleep, gets its own process ID. When you're working with an operating system that has both the GUI and the terminal, sometimes you can choose how you want to launch your program. For example, we can go into our applications here, and we can launch software such as GIMP for photo editing, and we can run it that way. Or we could launch it from the terminal. And when we're doing this, we might want to put it in the background automatically. And that becomes pretty handy. And a benefit of this is we actually get some extra information we might not have got if we launched it using the GUI. Obviously, if there's any kind of errors or issues, such as failing to load a module, you can see that information here. And we should be able to go on continuing with our execution, and we can see that process using PS. Well, it's right here. We can also see this by typing jobs, and we can move GIMP from the background to the foreground using the FG command. So now we are back to the GIMP process. We can continue to see anything that shows up in the terminal here. I don't think GIMP is very terminal heavy. So, I mean, even when we're drawing and stuff, it doesn't show up anything. But if it were to show anything in the terminal, you could view it that way. Now, when we bring a process from the background to the foreground, we might run into an issue where we can no longer type in the terminal. You see, none of these commands are recognized, and I can't seem to do anything. So what exactly is the solution to get a running process that's in the foreground back into the background? Well, generally to send stuff to the background, you would say BG. However, that's not working because it's currently running. So we need to actually pause the execution using Control Z. And you can see it says stopped GIMP. GIMP is still open, it still exists, but we can't do anything on here. And it says it's not responding. We'll say wait, we'll go back to the terminal, and now we can send this to the background like so. Now we should be able to type whatever we want into the terminal. It works, and we should be able to go back to GIMP and start using it again. So that is how you take a currently running process that's in the foreground, pause it, and then relaunch it in the background. A similar thing works if you have that running process and you want to temporarily use the terminal and then bring it back to the foreground. Same thing, you would say Control Z to pause it, issue whatever commands you want, and then you can bring it back to the foreground with FG. Now I want to go through an example of what if you have multiple programs in the background and you want to decide which ones to bring to the foreground. It can get a little bit more complex. So let's launch a couple of programs and I'll show you how to do that. So I'm going to close out of GIMP with Control C, which you can see closed it over here. We're back to our terminal. So we'll start with an instance of GIMP. I'll put that in the background. That'll launch. And let's launch something else, maybe VLC, and we'll put that in the background as well. That launches VLC player. Let's try one more application. We will say Firefox, and we will also launch that in the background. So there we go, we have that open. And now what I want to do is I want to take a look at our jobs. You can see we have 3 things running: GIMP, VLC, and Firefox. Firefox immediately said done. I'm not really sure what that's about. Let's launch something else. We'll say calculator and launch that in the background. I actually think it's called GNOME calculator. Let's try that. Yeah, that's right. I just gotta spell it right. All right, there we go. That was way harder than it had to be. So now when we say jobs, we have GIMP, VLC, and GNOME calculator. To choose which of these processes we want to work with, we use what's known as a job spec, which is pretty much a % and a number that is associated with each of these jobs. So you can see we have 1, 2, and 3. What I want to do is I want to start with a clear screen, and now I want to bring one of these into the foreground. So again, we have, let's say we wanted to bring VLC into the foreground. We would say FG %, and then the number that's in square brackets here, FG %2, and this will bring VLC into the foreground. We'll put that back in the background, so Control Z, background, and now we can see all of them in the background again. Let's try to bring that calculator into the foreground. Foreground %3, and now we're on the calculator. So this is pretty much if you want to see any of the terminal output for each one of these programs, you can bring it into the foreground and watch as it does stuff. Obviously that program will have to have stuff written to the terminal for it to show up. Not everything's just going to show up. You can see I can use this program without anything showing up in the terminal, but that's because it's primarily a GUI based program. Let's go ahead and we'll put that back into the background, clear the screen, and I wanted to go back to the PS command. You can see we have some extra stuff running here, but these are all things that have been executed from this terminal instance. This TTY refers to what terminal it was executed from, where this one is the terminal we are in, and you can see they're all the same. If you pass in an additional option X, we will get all of the processes. You might want to pipe this to less so that you can scroll through this list, and then when you're done, hit Q. If you want to know more about the PS command, you can use the man pages or do some research online. Another command I wanted to show you real quick is the top command, which is going to show the processes that are consuming the most resources. So we just say top. Every few seconds, this list will refresh, and it gives a lot of additional information you might not see other places, such as the CPU percentage, the memory percentage, the user who owns this process. And in addition to all the information about each process, there's a lot of general information for everything, such as the time of day, it's 8:20 a.m., how long the computer's been online, in this case 5 hours. We got one user on here. Then we have the load average over the last minute, 5 minutes, and 15 minutes, which we might get into that more later, but not really the focus of this video. The number of processes, and then information on the CPU usage. This is for user processes, and then this is system processes. And then we have NI, which stands for nice, which are lower priority processes. Then we have idle. So the majority of the processor is idle right now. We have 0.8 waiting for I/O. And there's a few other things in here, which if you want to know all the details about this, you can just reference a document such as this one. But I just wanted to give you an introduction, an overview of this command and know that it's an option. You can probably find some information as well by saying man top and scrolling through here and finding whatever you need to find. So that's going to come in handy if you are regularly managing processes and want to know the state of the computer. So that gave you a little bit more practice working with the background and foreground and getting an overview of the processes on the computer. Hopefully this video was helpful. Stay tuned for the rest of this series. We're going to continue to learn more stuff. Thank you for watching, and I'll see you in the next video. Peace out. Hello everybody, my name is Caleb. In this episode, I'm going to teach you how to kill processes. So this is pretty much a way to send signals to processes inside of Linux to force them to do something. So usually that's killing the process or closing the process if it becomes unresponsive or you need to close out of the program. So you've probably had the experience where you're working on something and the program you're using freezes. It was probably a scenario where, let's say, you were editing some video or working on some project for like 13 hours straight without saving, and then the program just crashes. Sometimes when this happens, you have to force quit the program. In the world of Mac, you go up to this little Apple symbol and then force quit, and then you can select what program to quit. In the world of Windows, you can open the task manager, and then you could have some application which you end task. So how do you do the equivalent inside of Linux? Well, to see the list of processes that you can kill, type PS, and you grab the PID of the process that you're just sick and tired of, and you say kill, and then type in that number, such as 78364, which in this case is GIMP. Hit enter, GIMP terminated, and now when we say PS again, it's no longer there. So that's pretty much it. You might be wondering, why did I need an entire video just to explain one word, kill, followed by the PID? Well, there's actually a lot of other stuff you can do. So this will send a signal to the program, and by default, this signal is known as term or terminate, and it's kind of the equivalent of closing out of an application by slapping the X button. Sort of like you need to slap the like button. But what if a program is completely unresponsive? Well, then you need a stronger way of closing out of the application. So the way you do this is kind of funny, but pretty much what you're going to do is you're going to say kill, and then just to be sure, you're going to put a hyphen and then kill again in all capital letters, followed by the PID of some process such as this one here, 79942. Hit enter, and now that process no longer exists. So if you want to super kill something and not just kill it, then you'll just pass the hyphen kill in all caps. That'll 100% kill the process, and this is basically the equivalent of force quitting that process. So it's kind of strange, why do we pass kill in all capitals right after we issue the kill command? Well, pretty much the first kill, the lowercase kill, is the command. Then the uppercase kill with the hyphen is an option to this command. Well, there are other options, and all these options are known as signals, so we can pass different signals to this command to do different things. And you'll see this used in other commands as well. So an example of this is if we put something in the background or the foreground, we're actually passing signals. So I've already killed all of our processes, so let's go ahead and start another one. We'll say GIMP and put that in the background. And if we wanted to bring that to the foreground, we would say FG, and then back to the background with Control Z, BG. So when we issue commands such as Control Z, we are issuing a terminal stop signal, and then when we reinitialize that by saying foreground or background, we are sending a continue signal. We can manually issue these signals, so if you say PS to look at the processes, let's say we wanted to pause GIMP here, we can say kill hyphen TSTP for terminal stop, and then the process ID 181763. And taking a look at this now, it's currently stopped. We can continue in a similar fashion, but this time saying CONT and passing in that same process ID 763 here, and that'll continue the process. and you see it's back to normal. You can get a full list of all of these different options by saying kill -L, and that's going to put a table. And you can see they're a little bit different here where they start with SIG for signal. That's optional, but you can do pretty much the same thing with SIG at the beginning. So if we scroll up to where we paused our process, we issued number 20 here, SIG TSTP. You could just the same put SIG here and it's going to work. So you can see it's currently stopped. And we could as well do SIG cont. There we go. So let's take a look at those again. Kill -L. So far we've talked about 15, which is the default if you don't give any extra options. We also talked about 9, which is if you force kill. We talked about pausing or stopping and continuing. You can also use the number here as well. So for example, if we wanted to kill the GIMP process, we would say kill. And we could use 9 here, so we'll say -9. It's a hyphen, it kind of looks like -9, so it's kind of confusing, but just know that you prefix with the hyphen there. And then 181.763 for that process ID, and there you go, it closed out of it. There's also 2 other important ones I wanted to talk about, which is number 1, SIG hup. This is the equivalent of what happens when you close out of a terminal which has software running in it. And then there's 2, which is SIG int, which is the equivalent of Control-C. So there's a lot of various ways of closing applications, so you'll see a couple of these in your lifetime, I'm sure. Now there's actually 2 classifications within these signals. One classification is signals that the application or the process receives and can choose to obey, and then the other, they don't have an option because they don't actually receive that signal. So when we used the all uppercase kill, this is not actually given to that process. They don't have the option to ignore it. The kernel's just like, rip, you're dead. So the other classification is when the process does receive the signal, and this would be, for example, the default, which softly closes a program. The program can take that kill signal and shut down. So to explain this difference real quick, if you take a look at 19 and 20 on this list, we have stop and terminal stop. 20 is received by the process, and that process has the ability to stop or pause, where 19 is not received by that process, and it will be stopped whether the process likes it or not. So this option cannot be ignored, whereas this one can. Another option is the kill all command, which will allow you to kill a process by name, but it'll kill all of those processes that have that same name. Say we launch an instance of gnome calculator. It's like the hardest word to type, calculator. And we'll launch that in the background. And we'll do this a few times. And this software is handy because it will actually launch 2 instances. So let's just go ahead and launch a few of these. And now when we say PS, you can see we have lots of gnome calculators. So what we can do is we can say kill all gnome calculator, which I think you put the R there. Let's find out. Yep, there we go. So it terminated all of the gnome calculators. And similar thing, you can also use signals. So if we went ahead and launched some more calculators, we could say kill all TSTP for a terminal stop. Same thing as Control-Z. And then gnome calculator. There we go. So now we have all of those processes stopped, and we can resume all of these with cont. So that's an introduction to kill, signals, and kill all. Hopefully this was a really helpful video getting you started in this world of killing processes. Be sure to stay tuned for the next episode where we're going to talk about... Yeah, I got nothing. All right, stay tuned. Peace out. Hey, what's going on, everybody? Welcome. In this episode, we're going to talk about the Tmux software, which is a third-party software we can install that will allow us to manage numerous terminal sessions, all within a single terminal window. It's very handy if we have different things we want to manage, especially if we can only have one terminal window. Let's say we're remoting into a computer with SSH. You might not just be able to open a new terminal window or a new terminal tab, so you're limited to just that single connection. That's where Tmux is going to come in handy. Now there is a competing product known as Screen, which if you want to know that, I did make a video on that in my prior life, like 4 months ago, back when I had my luscious mane. But, things change, so here we are today, and we're going to try a new software, Tmux. So first thing you need to do is you need to get this software installed. So sudo apt-get install Tmux. That's going to download it, and now you should have Tmux installed, and you should be able to say Tmux. Hit enter, and it opens a new window. It looks like it just kind of cleared out everything and gave us this green bar at the bottom, which looks cool, but so far, not a whole lot of useful stuff. So the very first thing you need to know is to exit out of this when you want to leave and you can't. You hold Control, press B, and when you do that, it says, hey, I want to issue a command. Then you hit X. Now it's going to give you the option, do you want to kill pane 0? Yes or no. Hit Y for yes, and it's exited. So that's an important thing to understand. Whenever you want to issue a Tmux command, just hold Control/B, and then followed by whatever key for whatever command you're trying to issue. X being exit. That's how you use Tmux when you're inside of a Tmux instance. Now, there are commands you can issue before entering a Tmux instance, such as Tmux ls, and that's going to list any of the instances running, which right now we don't have any. But what we can do is we can create a new Tmux instance, like so, and we can close out of this session without actually killing this process. To do that, again, Control/B, and then D for detach. And you can see it says detached from session 0. Now when we say Tmux ls, we have 1 here. So that's running in the background. And you should be able to reopen that by saying Tmux attach session. Hit enter, and it reopens it. So to show you that again, we're going to say something in here just so we can see some output. We'll say Control-B, D for detach, and then Tmux attach session. And you can see it keeps all of that information there. Now you can also name your sessions if you have a lot of things going on, you want to keep it organized. I'll show you how to do that. But just a quick note, if you do have a Tmux session running and you're trying to detach, but instead of hitting Control-B and then D, you just do Control-D, that's actually going to exit out of Tmux and kill that session. So when we say Tmux ls, you can see it says nothing. So just be careful of that. If you don't want to X out of it, make sure you hit Control-B first and then D by itself. But anyways, let's talk about now how to name a session. We'll say Tmux new and then -s for a session name. And here we'll just call it something like coding. That'll open the coding session. And within here, we can start working on some scripts. So let's say we had a file called script. We can execute it like so, which I created that earlier in an earlier video. It looked like this. That's the code inside of this script. But what if we wanted to basically execute code in one half of a window and have another terminal window to actually work in a text editor such as Vim or Nano or something like that? You can split your window into 2 panes by saying Control-B and then %, and that'll split it like so. Now you can also zoom out if you need to see a little bit better. So on one end we could say nano script to open that file, and then we can execute it on this end over here. You can switch between the 2 panes with Control-B semicolon, so you can see the cursor's over here, and then Control-B semicolon. Now the cursor is right here. So let's go ahead and execute this real quick to see what happens. Control-B semicolon. We'll execute the script. It waits a second and says hello world. Now let's say we wanted to change something, make sure it's working. We'd say Control-B semicolon and say, oh, we don't want to say hello world. We actually just wanted to say hello internet. And then we could save with Control-S and then Control-B semicolon to switch back. Then we can reissue the command and it says hello internet. So that's how you can edit and execute code in the same terminal window. Now there's actually numerous shortcut keys you should be aware of, and shout out to linuxize.com for listing these out. So we just did Control+B semicolon, which will toggle between the current and previous pane, I'm sure we could split it more times if we wanted. Let's try that out. If we said Control B, and this time we'll use double quote, and that's going to split top bottom. And now we can use another one of these shortcut keys, Control B plus O, to go to the next pane, which we can use to cycle through these. So Control B O, now we're working on this one over here. Control B O, now we're working on this one over here. And then Control B O, we're working on this one down here. And then when we're done with a pane, we can exit with Control B X. So we'll Control B X, kill pane 1, yes. And then we can detach from the whole thing again, Control B D, and that'll just remain inside of our sessions. And you can see that right here, coding. Let's say we created a new session, and this one we'll just call testing, and we'll exit out of this. Now when we list, we have two different sessions going on. We have one called coding and one called testing. When we want to restore one of these, we can pass in the name, such as coding. We'll actually add in a T option here, and that'll open it. So that is an introduction to Tmux. Obviously, it's pretty complicated if you're new, but it can be handy. It's probably a good tool to have if you want to execute a bunch of stuff in the background and pretty much turn a terminal into a more interactive experience where you can effectively use your computer and not just one terminal session. So it's pretty handy, good to know, and thank you all for watching. If you have any suggestions for other tools to cover, drop them in the comment section below. Would really appreciate that. And stay tuned for the upcoming episodes. Subscribe!